Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is Postgres all about and its architecture. So the first slide is about the introduction. So what is Postgre and why it is so famous over a period of time? And this is one of the most sought database nowadays. So one of the most important feature of your Postgre database is it is an enterprise class open source relational databases. It can support SQL, which is a structured query language, and JSON, both format for querying, and it is there in for more than 20 years with the community development. If we talk about the usage, it can be used for the data store. You can use it for data warehouse, you can use it for geospatial application, you can use it for analytics. You talk about anything and it is available. It is good for all the data types, and it is well suited for all the advanced data types. And in terms of the performance, it is good like any other database which is licensed and which is very costly. If we talk about the features, Postgre is having the MVCC architecture, which is multi-version concurrency control. That means, let's say if I have fired a select statement from EMP table at one particular point of time, in a particular row I wanted to fetch, and at that same time the row has been updated, then there will be some inconsistency if I try to read data. But what happens when such operations happen, there will be a snapshot available of the previous data so that the data don't get messed up. Although this is not the feature which is only available in Postgre, but all the relational databases like Oracle and others, they do have this features inbuilt. And the important thing is this is free of cost. This is open source. And you have the granular access controls. You can give the access to the particular database to the role, or you can give access to the tables, views, or the procedures, triggers, a particular column. You can give the access. So those things you have the granular access control. You have the concept of table spaces, or the other than your default table space, you can create a separate table space. You can keep all your data over there, and that will be useful when you are trying to take the backup. So it is just a logical kind of separation from other databases. There's a feature of asynchronous app or application, which is very good in terms of Postgre. The backup features that is tremendous in Postgre. You have the online backup. What you can do is at one particular point of time, if you wanted to restore your database, you can use the hot backup using uh, PG base backup, wherein something called as the log files, which is known as the write ahead logging, that will be enabled. If you take a backup of your base backup and all the files which are there in val, which is write ahead logging, if you take those backup, you can restore at one particular point of time, and that is useful when you create the standby database or the your application environment. It has the support for the international character set, so that is one of the other important feature. No wonder whatever the size of your database, it is going to support that. And when we talk about the fault tolerance, the write ahead logging features make it perfect suited for any particular disaster recovery when you have to recover your database at one particular point of time. Licensing, this is always bothering the organizations. If you talk about the famous RDBMS, you pay the cost in terms of the codes which you are going to use. Let's say talk about the Oracle, then you have to pay a lot of license cost. And if we are talking about Postgre, there is no license cost. And uh, more if you're going to use it on a compute where the number of CPU cores are more, then we always fear of paying more license cost to the proprietor, that is the organization from which we have purchased, let's say the Oracle Corporation. What in case of this Postgre, that if it is open sources, who's going to support it? So there is a dedicated team of contributors and those who continuously work on it. If there are any bugs, they are fixed, and the new versions are released over a period of time. So licensing, it is open source, and you have the code. You can use it, and you can use it any way you want it to. If we talk about the history of the Postgre, so PostgreSQL project was initially launched by Michael Stonebreaker at Berkeley University, which is University of California, I believe. And the original name was Postgre, which refers to the older version of the Ingress database, which was famous at one point of time. And I believe this project was kicked off in 1985, and after 10 years of development, this project was renamed to PostgreSQL because of its support for the structured query language. So who supports or who works on the development of this product? If there are any bugs or fixes, who does all this? So this is done by the PostgreSQL global development team. If we talk about the language support, that is awesome. It has support for Python, Java, Perl, .NET, Ruby, uh, C++, and ODBC. Everything is there. Let's talk about the architecture of Postgre. So it is a client server model. So the client sends a request to the Postgre environment. So Postgre, we have something called as memory parameters. So we have memory in the center. Then we have outside we have the background processes. So the main process when the server starts, there is something called as postmaster. So when an application, when there is a request from the client, it comes directly to the postmaster. The postmaster will check if it has all the required permissions to log in into the database. If it passes that, then there is a Postgre process spawned, and then the actual work begins. So let's say a select statement has been fired, and that is stored in the data file. Then first of all, those values come to the shared buffer, and the Postgre is going to read it from there, and then the value is returned back to the client. So the application connects to the the postmaster process. The postmaster checks the application right, and if it is successful, then it connects the client application. The instance doesn't write or read the application directly to the data files. It puts it there in the shared buffer. And the Postgre process acts on shared buffer and val buffers. Val buffers is if let's say some data modification has happened, then this particular buffer area will be dirty, and using the write ahead log background process, those will be returned to the val files, which are kind of log files wherein all the information will be returned, and then that piece of information will be permanently saved to the data files when there is a commit. So it is awesome in terms of the kind of work it does. Then there is a checkpointer process as well, which checks checkpoints, and at one particular point of time, your database will be in consistent mode, so that the data in the data files and memory that will be flushed to the data files. So this is just a basic. So we have the memory area, we have shared buffer, wherein the red value of from the data files are there. Then you have wall buffers, wherein any data which is supposed to be, which is changed, it has to come into this area, and using the wall, it is returned to the data files. Then you have work memory and maintenance work memory. If you have enabled the archiver, then the wall files are moved to the archived wall files. So this is just the same diagram. So we have the post master process, which is the main process. Then we have Postgres process. Then these are the some of the important memory areas: shared buffer, wall buffer, work memory, maintenance work memory, and then you have some of the important, very important background writer, which writes the dirty buffer to the data files. Wall background process, what it does, it picks up uh, the uh, the the changed value from wall buffers and write it to the wall files. If you have enabled the archiving, then it will be finally returned to the archived wall files. Uh, the next one, it is just a description of the different. So when you say systemctl status and PostgreSQL, then it displays you these processes. We'll see it on the demo. So the first process, which is spawned after the postmaster, is the logger. So what it does, it writes the error log file to the log file. Then we have the checkpointer. When a checkpoint happens, so there are some predefined interval wherein the checkpoint happens, and all the dirty buffers, the data which has changed, it is returned to the data files. Then you have writer. Writer again, this is the background writer, which it periodically writes the dirty buffers to a file, otherwise the checkpoint happens. Then you have the wall writer, which is a background process which picks up the information from the val buffers and write to the val files. Then you have one of the very good feature, which is called as autovacuum launcher. So it is kind of releasing the unused space when there are a lot of inserts, update and deletes, and a lot of space has been released in the tables. Then it does a maintenance work on that. So we'll have a separate discussion on that. Then we have archiver. So when you have the wall enabled, so write ahead logging enabled, and you wanted to keep all the transaction logs, so you have to enable this so that you can safely recover your database at a one particular point of time. Then you have a stats collector. Uh, it will tell you about the table usage, statistical information. So these are the background processes which are spawned when you start your uh, uh, Postgre instance. Memory area, you have shared memory wherein database caching and the transaction log caching happens. Then you have shared buffer. So this term you can see in almost all the versions, all the engines of the database. So what it does, it minimizes the disk I/O, and what it does, it puts all the bigger tables into the buffer, and it minimizes the access time when it has to pick the data from the data file. So puts it into the shared buffer. Then you have the wall buffers. What it does, it temporarily stores changes to the database, and when it has to write to the wall files, the wall background process picks it up from the wall buffers and write it to wall. It is useful for backup and recovery. Then you have the postmaster process. So what is the postmaster process? The postmaster process is the first process which is started when you start your PostgreSQL instance, and it performs the recovery. It initializes the memory area. It runs the background processes, and the last, which is last but not the least, which is your work memory space, maintenance, work memory, and temporary buffers. These are the different memory areas which are used for sorting. So when you say work memory space, this is used for sorting and temporary bitmap operations and hash join. So the default value is 4 MB, and maintenance work memory if you have the auto vacuum enabled. So and this is used for mainly for your create index and vacuuming. Temporary buffer, this is used for the temporary tables in case you use the temporary tables. And that's it. So we'll see a very small demo which says systemctl status. So let me fire this. Systemctl status PostgreSQL 12. So when you fire this, you will say that the status is running, and you will see all this. So you have the process ID. The main PID is 1115 postmaster, and this is what we had spoken about in the architecture. This is the first process, background process, which starts, and then the other processes are started. Logger, which logs all the error message file in error log. Then you have the checkpointer. Then you have background writer, which writes the dirty buffers. Then you have wall writer, which picks up the information from wall buffer and write it to wall files. Then you have auto vacuum launcher. It writes it does the auto vacuuming work, like when you there is a create index happening, or when it has to release the space, unused space in a table. Then you have the stats collector, and then you have logical replication launcher. So this is basic of the architecture of your uh, of your Postgre environment, and we'll quickly do a recap of what we have done. So we talked about the introduction of Postgre environment, why this is so famous. Then we talked about different features. We talked about the licensing, which is free, open source. Then history of Postgre. Then the architecture, memory architecture, background processes, and different physical data files where it is written. And then we discussed about how the data is flown when a client requests the information, and the, the definition of different background processes, and memory areas, and the work memory area related components, and that's all. Then we checked the system CTL status PostgreSQL 12. Then we saw different background processes. Then we saw one more thing. You can see the PS3-P1115. So this shows like what is the relationship. So postmaster is the base. From here, rest of the background processes are spawned. And if you see 1271, it corresponds to the logger. I hope this is going to help, and thanks for watching. E-MultiSkills video tutorial. In this video tutorial, we will learn how to install Postgre on Windows. So this is the list of steps which we will be performing on installing the PostgreSQL on Windows. First step is downloading the executable. Second, we will install the PostgreSQL from the binary or the executable that we have downloaded. And in the third step, we will access PostgreSQL using command prompt and pgadmin4. So let us start with the first step. So what we are going to do is we are going to download PostgreSQL. So in your browser, just search for download PostgreSQL, and you will see the first option, downloads hyphen PostgreSQL. Just click that, and we have to do it for Windows. So just click Windows. And then the first option, Windows Installer, Interactive Installer by Enterprise DB. So just download the installer. So here you can see that table which says the first one is PostgreSQL version, then which operating system it is, and that's it. So we are going to go with the latest version, which is 12.3. The other versions are 11.8, 10, 9, 9.5, 9.4, etc. 9.3 is not supported. So most of the time when we download the binary or when we download some software, we get in touch with the application owner who instruct us like which version of PostgreSQL has to be installed. Since this is a demo environment, so I'm going with the latest version, which is 12.3. So just click, so you can see this download for Windows x86-64. Just click that, downloads, and the download will start. So I'm not going to do this because I've already downloaded the binary on my system. So I'm just going to start with the installation. So I have downloaded PostgreSQL 12 and we are going to install this on my system. So it is a Windows laptop, so we are going to install on that. The installation is very, very easy. There is nothing great like any other software which we install on Windows. It is like that only. So the tricky part will be when we are going to make some changes on it. So I'm waiting for the first screen to appear. So you can see that setup PostgreSQL, welcome to PostgreSQL setup wizard. So just say next. And the first screen which comes up, it says the installation directory, the location where all the data files will be located. So we'll go with the default location, which is C program files, PostgreSQL/12. Just say next. And there will be four options which will be installed by default. The first is PostgreSQL database server. We are going with that. The second is pgadmin 4, which is a graphical tool for managing and accessing your PostgreSQL database and the server. Then we have something called as Stack Builder. If you download and install this, this will help you in installing additional tools, drivers, and applications. So this is good to have this. The fourth default option, which will be downloaded, is the command line tool, like your pg base backup, pg dump, or pg restore. So these will be installed by default. So let's go with all the default options. First is the database server, then pgadmin tool, which is a GUI tool. Then is a stack builder, which we should include in case we wanted to have something extra downloaded later on. So this is required. So command line tools, this will have all the command lines tools installed. So just go with the next. And please provide a password for database super user. So this you have to remember. This is the database user, which is Postgre, and this is a super user. So I'm just giving some password. Make sure that you remember this, because when after the installation for the first time when you access your database, you will need this password. Please select the port number. So by default, PostgreSQL works on 5432 port number. We'll go with the default locale, so this is fine. Just go next, and you can see that there are a lot of things like installation directory. By default, all the data files will be here, and C colon program files PostgreSQL 12. This is your installation directory, and data directory is also same. Database is on port 5432. It is listing on this port, and database super user is Postgre, and rest of and I think that that's more than sufficient. Just go with the next, and this is going to install Postgre on the system. This is going to take at least 20 minutes for the time being. I'm just going to pause this video. So once it is installed, I'll resume it, and then we will see how to access PostgreSQL database using command line and pgadmin 4. Welcome back. The installation has just finished. Now you can see the final screen which says completing the PostgreSQL setup wizard. So I'll just press finish as the installation is finished now. So this is the stack builder screen which will appear in case you wanted to add some more drivers or features, so you can use that. So just I'm saying cancel and my installation is done. So now the next step is just go to your Windows screen and look for Postgre. So this was PostgreSQL 12, so we are here, and you need to look for SQL shell. Just click that and you will see a screen which says server localhost. Yes, we wanted to log into the same host, so it will be localhost. Just press enter. Database is Postgres, Postgre, which we wanted to log in. Port is 5432, the default one. Username is Postgre, that is fine. And now it will prompt for the password. This is the same password which you have feed in earlier. So just provide the password, and you are on to the Postgre SQL command prompt. So just say /l, and this will list down all the databases, or /du. This will list down all the the roles which have been created. And now let's do one more thing. This is how do we access using the command prompt. In case you wanted to access it using the pgadmin4, just go to PostgreSQL folder and look for pgadmin4. This is the GUI tool which is used to access your uh, PostgreSQL. The management is very easy. Everything is there in the GUI mode, so it is good to have this handy. And so I have just clicked the pgadmin4, and this is coming up. So this is management tool for PostgreSQL. And now you can see on the screen it is saying starting pgadmin4 server. So this should come up any moment. So it is appearing in the browser, localhost colon 57414/browser. And let me reset the master password for pgadmin4. So I've set in the password for pgadmin master, and now you will have to connect to the PostgreSQL 12, which is installed on your local system. So it is saying please enter the password for the user Postgre to connect to the server PostgreSQL 12. So just feed in the password and say OK. If everything is fine, then it will connect. You can see that there are some things populated downwards. If you click the database, this will show that by default there is a Postgre database which is installed and owned by Postgre role. So this is created, and there are a lot of things in some other tutorial we will see how to use it, but this is how do we connect to Postgre SQL using command prompt and pgadmin GUI tool. So just a recap of what we have done. We have installed PostgreSQL on Windows. We downloaded the executable from the from Enterprise DB. We went with the latest version, which is 12. Then we installed using the PostgreSQL installer, and then we access the PostgreSQL using the command prompt and pgadmin4. Just you need to remember that the Postgre password which you have provided during the installation, that you need to remember, so that you can connect using the command prompt and pgadmin4. So this is the basic of how do we install it on Windows, but there are a lot of things apart from this. So in some other tutorial, we'll see how to work on those. For now, it is bye from me, and see you in the next tutorial. I hope this is going to help, and thanks for watching this. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn how to install Postgres on Linux 7.5. I have listed all the steps on this notepad. So we are going to install PostgreSQL on Linux or Postgres on Linux. The setup which I have is having RHEL 7.5. I do have access for the root, and there is an interconnected internet connectivity onto the Linux 7.5 on my system. I'm already logged into the system using MobiXterm, which is a GUI tool which can store your user ID, password, and IP address. So I'm already logged into that. So you can see I can ping internet, or I can access the internet. So I can ping google.com. So what I'm going to do is I'm going to install Postgre on Linux operating system. The first step which we do is actually we have to install it using the yum repository, and all these steps are already listed. So if you go to postgresql.org, you will be able to see all the steps which are required to install Postgre on the system. So let me log into to and just say postgresql.org and download, and you will be able to see how do we install Postgre on any operating system. So I'm in the download section, and if I go to Linux Red Hat, just click this, and this will open another section wherein what we are going to do is we are going to install using PostgreSQL yum repository. If you scroll it down further, you will be able to see what version of Postgre you wanted. If so most of the time when we install Postgre or any other database version, we go according to the requirement of the application owner. For this demo, what we are going to do is we are going to install the latest version of Postgre. If you click this, you will be able to see all the versions. So it is 12, 11, 10, 9.6, and 9.4. Let's go with the latest one. And the platform which I'm having is Red Hat Enterprise Linux 7. So click with that. Architecture which I have is 64-bit, so this is fine. And these are the steps. In the first step, you have to install the repository RM. Just copy and paste this one. Then install the client packages if you want that, and you can install the server package. And in next step, there is a command /usr pg sql12 bin postgresql12 setup. In this, so it is going to initialize the database. Then we are saying systemctl enable postgresql12. So in this, what we are going to do is we are going to enable the Postgre. When the system restart, your Postgre should come up automatically. Then we are going to start the Postgre using systemctl start and PostgreSQL12. So these all the steps I have listed on my copied on my notepad. So I'm just going to run them one by one. So this is the first step which I'm going to perform. Just remember I have logged in as a super user onto the Linux operating system. I'll just say yum install, and it is going to download the repository. Then we are going to install using that. This takes a couple of minutes. So it's so installation on Linux operating system using the yum is really simple, and it's very fast. So we have the next step is yum install PostgreSQL12, which is installation of the client section. Then we will go and install PostgreSQL12. 12 is the version. So it is going to download related packages. It is checking the dependency like what all RPM it has to download. It is just very small in size. It is just 9.8 MB. I'll just say yes again, and this will be installed very fast. These are some of the warnings which are due to missing links, which is already, in fact, the this already exists, so we can ignore that. So just say yum install PostgreSQL 12/server. So we are going to install server and the client both on RHEL 7.5. This is going to take very less time, and this will be up installed very soon. So you can see installed PostgreSQL 12 server is installed. In the next step, what we are going to do is we are going to initialize the database. So it is the command is /usr pgsql -12 bin postgresql -12 setup init database. So it is going to initialize the database. Once it is initialized, we will enable it. Enable. Okay, this is done. Just say systemctl enable PostgreSQL -12. So when the system restarts, your PostgreSQL comes up automatically. Let's start the PostgreSQL. Systemctl start PostgreSQL -12. It is done. Now let's check the status. So we'll say systemctl status PostgreSQL 12. You can see the database status is active and running. So we are done with the basic installation of PostgreSQL 12 client and server. Now when the Postgre is installed on the Linux, it creates an OS user with the name Postgre. So if you go to cat/etc/passwd grep and check the user Postgre, you will be able to see that there is a user called Postgre, which is created during the installation. And this is the default role which you have to use for working on Postgre environment. So this will have the sudoers already available. So what we are going to do next is we are going to log in with the Postgre OS user. So we'll say sudo -i-u postgre. This is not, this user ID on the operating system is not created separately. This comes as part of the installation. So we'll say sudo -i-u postgre. And if I say now ID or who am I, I'm the Postgre user which is logged in. So we installed the Postgre 12. We switched to the user Postgre on the operating system. The next step is we will log into the pSQL, the PostgreSQL command prompt. So after logging to Postgre user ID, I'll just say pgsql, sorry, pSQL. So you can see that I'm connected through the Postgre command prompt. So you can work from here. So you can just say do. So this will display all the roles which are available as of now. So there is a role which is called as Postgre. This is the super user inside Postgre instance. So I'm logged in the Postgre command prompt. If I have to come out, or if you wanted to see more on this, just say help, and this will display all the commands which you can run over it. To come out of this, just say /q, and you will be out of the command prompt, and you will come on to the Postgres OS user. So as of now, we have used the OS user Postgre. We saw that there is a default profile, a default role called Postgre is available that can be used, but that is like a super user. So what we can do is we can create a new user that can be used later on. So just for this, I can just say post create user hyphen hyphen interactive. I'm doing all this on the OS, on the operating system, using I'm already logged in as Postgre OS user. So enter the name of the role to add, just say test user. Shall the new role be a super user? No. Shall the new role be added to create database? I'll just say no. Shall the new role be allowed to create more new roles? No. And this is created. Just go to uh, the Postgre command prompt and say Postgre, uh, just say display the list of the roles. So you can see there is a role which is created with the name test user. So this completes the setup of installation of PostgreSQL 12 on Linux. So just a recap of what we have done is I have an operating system Red Hat 7.5 which is installed on VMware. I do have the access to root. I have internet connectivity, and we checked PostgreSQL.org download section. Then I checked the Red Hat section, and I checked and I selected the PostgreSQL 12. I wanted to install PostgreSQL 12, and this has displayed me this many number of commands which I have to execute. So we are using yum install first. In the first step, we downloaded the repository, then we installed the client, then server, then we initialized the database, then we have enabled the PostgreSQL, then we started it. And then we switch to the Postgre OS user because that is a user which is used for maintenance, or that is the default OS user which is created when you install Postgre on Linux operating system. So we switch to Postgre OS user, then we executed psql, which is Postgre command prompt, and then we listed all the roles using /du, and we created a non-default role, and uh, we came out of just to come out of this, just say /q, and that's it. I hope this is going to help, and thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn how to move data directory on Postgres in Linux 7.5. So these are the list of steps which we will be performing on a Postgres 12 database which is installed on Linux 7.5. So first of all, let's understand what is Postgres data directory in Postgres 12, which is installed on a Linux environment. So all the data files related to the Postgres instance is stored in a location which is known as a data directory. And over a period of time, the storage allocated to that gets exhausted, and either you need to extend the storage or you need to move the data files or all the files which are related to the database to a new location. So in this demo, what we are going to do is we are going to move all the data files to a new location. So the setup which I have is having the OS 7.5. I do have the access of root and Postgres OS user. The Postgres instance which is installed is 12. So I have already logged into to the instance to the server using the MoveX term, which is a GUI tool. You can store the IP address, user ID, and password. Just click and you will be able to log in. So I have already logged in with two terminals, one with root and another with Postgres. So let me walk you through the steps which we are going to perform. In the first step, we will log into PostgreSQL like sudo -u postgres psql, and we will check show data directory. That will show us the current location. As of now, the current location is the default location, which is /var lib pgsql /12/data. So in this demo, we are going to move all the data files which are located on this current or default location to a new location, which is postgres/data. So in the first step, we will identify the existing location and the new location. In second step, we will shut down the services using systemctl stop postgres 12. In the third step, we will prepare a new file system. I'll change the ownership of the new file system, which is postgres/12 to postgres: and the ownership will be given 750. And we will navigate to the existing data file location and copy everything to new location. In the step number 4, we will update the configuration file. We will added the postgresql.conf, which is located as /var lib pgsql /12/data postgresql.conf, and we will update data directory location with new location, which is /postgres/data. In the step number 5, we will start the Postgres, and step number 6, we will verify that the new location is updated or not. So let's start with the step number 1. In the step number 1, we are going to log in as a Postgres user. So I'm logged in as root, so let me say sudo -u Postgres psql. So I'm logged into Postgres command prompt. Now here you have to type show data underscore directory. So this will display the current location of the data directory. So this is the current location, and this is the same location which exists when you install the new version of PGSQL, PostgreSQL. This is the default location, so this has not been updated. So we are going to change this location to a new location. In the step number 2, we will check the status of Postgres. Let me log in. So you can see on this terminal, I'm logged in as Postgres. So you just need to say sudo systemctl status Postgres 12. So you can see that the status is running. What you need to do is you need to stop the service using sudo. I'm assuming we don't have the root access, although I have shown the first step as root. In the second step, what we will say is stop the service. Sudo systemctl stop system Postgres 12. Check the status once again. The status is inactive. It has been shut down. In the third step, what we will do is we will give the ownership on new file system. So let me quit out of this, and I'm logged in as root. So these should be done in advance. So what I'm going to do is I'm going to change the ownership of Postgres/data to Postgres: and the permission which we will be giving it to is logged in as Postgres. We will change the permission as chmod -r 750 Postgres/data. So let me see if there is any data, because I have done this demo earlier. So I need to make sure there is nothing. Yeah, so there is nothing in that. In the third step, we have verified the new location. We changed the permissions accordingly. Now we will navigate to the old location or the existing location, uh, which is var lib pgsql/12/data, and we will copy everything from this location to postgres/data. So we'll say cp-r star postgres/data. So this is very small, so it is copied immediately. Let's navigate to postgres/data and say ls-lrt. So you can see that the files are copied to the new location. Now in the step number 4, what we have to do is we will take a backup of Postgres configuration file, which is located at varlib pgsql12/data postgres So let's take a backup of the configuration file. We have taken a backup. Now add it the postgres So you can see we are inside the Postgres configuration file, and what I need to do is I need to update the data directory with the new location. So just uncomment and give the new location. In our case, it is postgres/data. So I have already added that, and you just need to uncomment and save it. This is saved. And in the next step, what we are going to do is we are going to start the Postgres service. Just start the Postgres service. And one more thing, you need to make sure that you can check the alert in case there is any issue. So just tail-10f/var log messages. So this will show if the system has come up perfectly or not. So it is saying started PostgreSQL 12 database server. Check the status as well. So we'll say sudo systemctl status Postgres 12. You can see that the status is active and running. So this is perfectly fine. And the last step is we will log in to Postgres command, and we'll say sudo-u Postgres PSQL, and we are on the command prompt. And here you just say show data directory, and you are done. So our new location is updated Postgres. So now onwards, whatever data comes into the database, it will go to Postgres/data. So we have successfully moved our data from existing location to new location. So what you can do, you can leave it as it for some time and delete the unwanted data later on. But it is a very small amount of data, so we can leave it like this. Just to recap, what we have done is we checked the current location of data directory, then we stopped the PostgreSQL, then in the step 3 we moved all the content from existing to new location. In the 4th step, we updated the configuration file. In 5th step, we started the PostgreSQL, and the 6th step we checked the new location, and it was done properly. I hope this is going to help, and stay tuned for next tutorial. Thanks for watching this. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn how to change or move the default data directory to a new location. I have listed all the steps in a notepad, and in first phase, what we will do is we will go through the steps which are listed here, and then we will perform the demo. So first of all, let's understand what is the default data directory in PostgreSQL. So in Windows, so what happens when you install the PostgreSQL on Windows, which you would have seen in my previous tutorial, that once you install the PostgreSQL on Windows using the run installer, then it asks you for the location of data directory. Either you mention the default location, which is mentioned in the C drive, program files, Postgre, then the version, and then data. If you do not want that location, which is not the preferred location, you need to dedicate a separate drive to the data file so that all the data files can store there. So whatever data goes into the Postgre database, it is stored in that particular location. So over a period of time, this keeps on growing, and either you need to add the storage or you need to maintain that particular file system or the drive. This is a background of what is data directory. Uh, uh, so what we will do is we will perform the demo in 5 steps. In the first step, what we will do is we will log into Postgre using the command prompt, and we will check the location of data directory using show data directory. And then we will stop the services. So make sure that you have a downtime to perform this activity. In the second step, what we will do is we will copy all the data from current data directory, existing data directory, to the new location. And in the third step, we'll check if the permissions are intact. And then in the fourth step, we will edit the registry setting. You will have to go to HKey local machine system, current control set, services, and then PostgreSQL. There is something called as image path. You need to change, modify the location to the new value. And then finally, we'll start the services. So let's perform the first step. In the first step, what we are going to do is we are going to log into PostgreSQL. So let me open the PostgreSQL 12 command prompt. So I'll log into localhost, database Postgre, default port 5432, Postgre database, and I believe password is password only. Oops, I believe there will be a okay, password I have mentioned wrong, so it has not taken that. So let me try once again. Server localhost database Postgres, port 5432, username Postgre, and this is the use. Yes. Now here you say show data underscore directory. So this will list down show data underscore directory. So this is the current location. So what we have to do is we need to so this is my current location, C drive program files, PostgreSQL slash 12 slash data. Since I don't have a separate drive, so what we will do, we will create a new folder with data underscore new, and we will copy all the data from existing location to data underscore new. And what we have to do is we have to stop the services. So let's go to services.msc, services.msc, and open the services. It's already open. So what we will do is we'll go to Postgre services. It is in the state of running. We'll stop this because we have to make some changes. It is stopped. I have two windows open. Okay, I think it's only one. And in the next step, what we will do is we have to copy data to new location. So let's go to the location. Where is my data file? It is in C drive, program files, and then PostgreSQL 12 and data. This is my current data location. So what I have to do is I have to copy all the content to a new location, which is data underscore new. So just copy and paste the entire content. So this may take few seconds to few minutes to several hours. It depends upon the data which is stored. So make sure when you do the new build, you give a proper location so that you don't have to redo this activity. So the location, so I have copied the data to a new location. I'm closing all this folders, and make sure you have proper permission over there. Then in the next step, what we will do is we will go to registry. So just say reg edit. So this will open your registry editor. Then go to HKey local machines. Then you have system. Then you go to current control set. Then you have services. And under services, you have Postgres. So this location is already mentioned in the notepad, which I'll put it in a comment section. Go to PostgreSQL x6412, and there is something called as image path. This mentions the location. So there is hyphen D followed by the complete location of the data directory. So the data directory has changed now from data underscore new data to data underscore new. So you just give the value between this comma. So just between inverted commas. So just say OK. Just cross verify if it is reflected. Okay, yeah, data underscore new is mentioned. Just close this as well. Close all the folders. Nothing should be open. PSQL, I think, yeah, open anything which is related to this so that it doesn't interfere when you are starting the service. And the final step is to start the service. So once the service is started, we'll log in. You can see that service started and is in the running mode. Now again, we'll go to PostgreSQL 12 command prompt and server localhost, and we'll give the password. Yes, we are able to log in. Just say show data underscore directory. So you can see that new location is updated, and any data which is created after now onwards, or you update, you create a database, create a table, insert, update, anything which modifies the data will come to this location. So this is how actually we do it. Now you can rename the older data, and you can delete it later on. So just a recap of what we have done is in this tutorial, what we did is we moved the data from current location to a new location. The current location was C drive program files PostgreSQL/12/data. We moved it to a new location, which is data underscore new. Since I do not have a separate drive, then we logged into Postgre command prompt, and then we checked the show data directory. So this suggested that it is on this particular location, C drive program files, Postgre 12/data. Then we stopped the PostgreSQL database using services.msc. We stopped PostgreSQL service. Then we copied the data from older location to new location. Then we added the registry using regedit, and PostgreSQL service was given the new location so that when the service started, it looks from this location. And finally, we restarted the PostgreSQL service. And at the end, we checked the new location. So it was using show data directory, it reflected the new location. I hope this was useful, and see you soon in another video tutorial. Thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn how to enable remote access to Postgres server. So I have listed all the steps in a notepad, and we are going to walk through that followed by a demo. So when you install a PostgreSQL, so by default connection to the Postgre are not enabled. So if you try to access the PostgreSQL server from remote server, you will not be able to access. You will get the message that PSQL could not connect to server connection refused. This is because this is the behavior by default. So if you have to enable the connection to the remote server, you need to make some changes, and in this demo we will see how to make those changes. So this in this demo setup we have two server. One is 192.168.1.61, which is my server where Postgre service is running, and the Postgre 12 is running over there. And we have a client with the IP address 1.71. From the client side, we will try to access the Postgre. So let me show you the setup which we have. So this is mobile Xterm. So I'm logged in to mobile Xterm to both the IP addresses. One is 192.168.1.61 and another is 71. So what we are going to do is, in the first step, let us check the status of uh, of the service which is running as of now. So we'll say systemctl status PostgreSQL 12. So you can see that a status is running, and if I have to log into the server, I'll just say sudo su hyphen postgre, and we'll just say PSQL. So this will take me to the prompt on to the local server. So if I say /l, this will list down all the database. So there is a database with the name node 61. So what we will do in this demo is we will try to access all the databases from the remote server. From the remote client. So the client IP address is 192.168.1.71. So how do we connect from the remote server is using PSQL-u. Username is the Postgre-h is, and the host name of the server where Postgre service is running. So we will run this command from the client side. So let me run this. So PSQL-u Postgre-h and the server where Postgre service is running. You can see that could not connect to the server, connection refused. But if I try to ping, this is pingable, the port is open, so everything is fine with that, but there are some settings which are not enabled, so we are not able to access it. So what we will do in this demo is we'll go through the steps. So there are three steps which we need to perform. In the first step, there is a file called as pg_hba.conf where we need to add the client authentication record. And once we open this file using the editor, I will be using vi editor, and this is the location in my case. And there is a section which is IPv4 local connections, and there I will mention host, all, and the IP address of the client slash subnet and the authentication method. This is the first step which we will do on to the Postgre server. In the second step, we will add it PostgreSQL.conf, and we will search for a parameter called as listen underscore addresses. By default, this is mentioned as localhost. So only the connection from the localhost is allowed. When we have to enable the connection from the remote environment, we have to mention the IP address of the server itself. If you have more IP addresses assigned, so you have to mention all those. So whatever NIC card it is listening, you have to mention the IP address of that. Please make sure that you mention the IP address of the server, not the client. The client IP address is to be mentioned only on pg_hba.conf. In the third step, we'll restart the service. In the fourth step, we will access it using the command prompt. So let's go to the first step. In the first step, let's log into PSQL and say show data underscore directory, and we will find the location where this hba.conf file is located. So you can see I have navigated to that step, And then what we will do is pg, we have to edit that file, pg pg_hba.conf. I'm using the vi editor, and then what you have to do is scroll down till you find IPv4 connections. And here you mention the IP address of your client. So I'll be mentioning it as host all IP address of the client and authentication using MD5. So let me give some spacing. And you can mention like which client it is, or you can mention the list of the IP address or the conditions also, which all are eligible to connect. So we have added the IP address of the client. Then in the next step, what we will do is we will edit PostgreSQL.conf file, and it is in the same location, data directory. And here what we will do is there is a parameter called as listen addresses, which is by default localhost. So you have to replace localhost with the IP address of the server. The IP address of the server where this is running is 192.168.1.61. The IP address of this server itself. Where I'm typing the command, this is the server only. Just save it. And in the third step, what we will do is we have made two changes. We have mentioned the details IP address of the client in hba.conf. And what in the second step, what we have done is we have edited the PostgreSQL.conf, and we have replaced uh, localhost with the IP address of the server. It is not the address of the client; it is the address of the server itself. The service is restarted. It is running as expected. Now we will try uh, to fire this command on remote server. So it is psql-u postgre-h. There's prompting for the password. I have mentioned the password for the Postgre user as password only. So you can see that I'm able to log in. And if I say /l, I can see that it is connected to the remote server and a node 61 database we created, and it is available here now. Or we can try one more step. We can create one more database. So we'll say create a database test now. And this should be visible here, /l. So test now is visible from the remote server. So this is the way we access the Postgre from a remote server. So just to recap, um, we edited pg_hba.conf, and in IPv4 local connections, we mentioned the IP address of the client. And then in step 2, we edited PostgreSQL.conf, and we replaced localhost with the IP address of the server. And then in the third step, we started the Postgre service. And in the fourth step, we tested the remote connections. So this is how we access the Postgre remotely. I hope this is going to help. Stay tuned for another video. Thank you. And welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is a password file in PostgreSQL. So this is all about the password file, which is occasionally used in PostgreSQL. So the password file is also known as the name of the file is .pg pass, which is password file in Linux system. So and it is available in the home directory of the Linux user who is the owner of Postgre software. So when you try to log into Postgre, let's say I'm trying to log in to PSQL using Postgre user. So if I say PSQL-u Postgre, it will prompt for the password. In case I wanted to avoid using the password, I wanted to keep the password stored in a password file, and the password will be read from there. So the file name in Postgre is known as .pgpass. Dot stands for the hidden file, and the password is saved in this particular file in text format. And when you fire PSQL-u Postgre, then the password is going to be read from this. That's the password file in Postgre environment. So what is the location and ownership of password file? So location of password file in Linux system is in home directory, and the name of the file is .pgpass. In Windows, it is in app data PostgreSQL, and the name of the password file is pgpass.conf. What is the permission on the password file? The permission on the password file is 0600 in Linux, and in Windows, the user who is using that particular software that should have the full permission on that. Then you have the permission to use the password file. Then what should be the kind of entry in the password file? When you added the pg password file, pg pass file, let's say in Linux, then you will see the format is with the 5 entries. First is the host name, colon port, colon database, colon user, colon password. And what is the usage of password file? The usage of password file is when you do some kind of automation and you do not want to feed in the password on the command prompt, then it is going to pick the password from the file. But it is sometimes so it is a kind of security breach as well. So what is the cons of using the password file? The pros is that you can store the password file in the text format, and your command is going to pick it from there. But when you put the entry in password file, it is visible in the text format, and anybody who has access to it can read it, and it is a kind of password breach. Now let's see the demo. So logged into Mova Extreme as let me close this session first. The Okay, this is my Linux system, and if I try to log in normally with the PSQL command, so I'll be able to do it using PSQL. Okay, let me write it manually. So PSQL -u username. Let's say I'm trying to use Postgre user on the port 5432, which is the default port, and if I enter, it is asking for the password. So let me feed in the password, so I'm able to log in. If I wanted to avoid putting in the password on the command prompt and I wanted to save it somewhere, so that is what we say is the password file. The password file location is in the home directory. So let me create a password file. If I say ls-asl, then all the hidden file with dot extension with dot prefix will be visible. So if I say vi.pgpass, I'm just going to create a new one. So in the beginning, let's add some kind of instruction like with the commented line, like format is as below. The first is the host name, then port, database, username, and the password. So let me put this detail, so I'll explain what it is. So I'll be logging to localhost on the port number 5432 using the Postgre user, Postgre database, and I'll be using the Postgre user, and the password is password. So now when we tried earlier, it was asking for the password. So now this time it should display it without password. And now it is showing that permission should be 600. So this is mandatory. So what I will do again is, it is mentioned over here. So you need to mention the special permission as well. Otherwise it is not going to read it. I have given the 0600. So if I say ls-asl, you will be able to see the permission. It is read write permission of the owner, which is Postgre. Otherwise nobody is having any other permission. So let's execute it once again. PSQL-u username-p port name, and you can see that we are able to log in without password. So this is the usage of using the password file. So just a recap, so format is in the host name, colon port, database, username, and the password. So what is the usage? That it contains the password which is used in the connection which requires a password. And what is the location? In Linux, it is in your default home of uh, the the software of who's the owner of the software. In PostgreSQL, it is Postgre, so it is present in the default home directory, and the name of the file is .pgpass. In Windows, it is available in app data PostgreSQL, and the password file name is pgpass.conf. About the ownership, in Linux, it should be 0600. In Windows, it should have full permission so that the software owner can read and write over there. And about the security, this is not one of the best way, because it is available in the text format, and anybody who has access to that particular folder will be able to read it, and it's a kind of password breach. So I hope this is going to help, and thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn how to use PostgreSQL all.conf on Postgre in Linux environment. So the first thing is, what is PostgreSQL.conf file? So PostgreSQL.conf file is a parameter file which is available on Postgre server when the Postgre server is installed, and the parameters are read when the server starts. When the server restarts, it means when the Postgre server restarts, and most of the parameters are global parameters, and they are read when the server is starting up. And let's see some of the facts about the server parameter file, which is PostgreSQL.conf. Like, what is the location of PostgreSQL.conf on Linux environment, and how do we change it? How do we check? So let's see a small demo. This is my PostgreSQL server. So I'll just say systemctl status PostgreSQL. Uh, the version is PostgreSQL 12, so you can see the status is active and running. So what I'll say is pSQL, and I'll be connected to the Postgre prompt. So by default, PostgreSQL.conf is located in data directory. If you say show data underscore directory, it will be available at this location. Or if you wanted to see the exact location, you will have to say uh, show config underscore file. So you can write show config underscore file. So this will give you the complete location of PostgreSQL.conf file, and you can view it using the view command, or if you wanted to modify some of its parameter, you can save the changes using vi, and Some of the parameters require server reboot, some of them may not require the server reboot. So that is a very interesting point, like how to check which one is requiring the. Okay, this is my PostgreSQL.conf, and how do we check the parameters? So it is the parameters are listed in pg underscore settings. So if you say select name comma settings from pg underscore settings, you will be able to see all the parameters. So you can see allow system modes, so it is in alphabetical order, so I think it is close to some 300 parameters, so 314 parameters are there, and you can see the values on the right side, the parameter name on the left side. Let's see how many distinct parameters are there. So we'll say select distinct context, context from pg underscore settings. So if there is a context as postmaster against any parameter, that means when you try to modify that parameter, at that time you need to restart your PostgreSQL instance so that the changes are reflected. So we discussed about postmaster context. Okay, let's move on to the next slide. How to modify PostgreSQL.conf parameter. So we checked how to check the parameter, and then we will see how to modify it. So let's see some of very basic parameter, like if I say show port, it will show me at what port this Postgre is listening. So it is listening at 5432 port number, or there is a very basic parameter which is max underscore connection. So if I say show max underscore connection, so there are 100 connections allowed at one particular point of time, and if you go beyond this you will not be allowed to connect it. So let's see how do we make changes to this parameter from 100 to 200. There are two ways. One way is either you edit the parameter file using BI editor and you restart the instance, or you can use there is something called as alter system. You just say alter system set max connection equal to new value. So in this case we are trying to increase it from 100 to 200. So I'll say alter system set max connection equal to 200. So let's do that. So it has changed to 200, but this requires a reboot, so this will not be reflected as of now. So if I say show max connections, it will still show 100. So where do we find like it has gone to? So let's go to the data directory and show data directory. I think we already executed it, and so this is the location of PostgreSQL.conf. cd one step back, and this is the data directory. So if I say ls-lrt, so there is a file which is called as postgresql.auto.conf. So if you view this file, you will be able to see the alter command which you just fired. So max connection equal to 200. So what happens when you restart your instance? When you restart your instance, this value is picked up from here. First of all, your PostgreSQL.conf is read, and then this PostgreSQL.auto.conf parameter will be read. So let us restart the instance. Sudo systemctl restart PostgreSQL 12. So instance is restarted. Just check the status. It is in the running mode, and now let's uh, log into the command prompt psql, and we'll say show uh, max underscore connections, which we updated using set parameter alter system. So you can set the parameter globally using alter there. So there are some parameters which are applicable for global. There are some which are uh, at what do you say, the session level. There are some at your user level. So you need to classify them. Okay, moving on to the next one. So there are different components which are available in PostgreSQL.conf. So there is something called so when you open it or when you view it using the view command or edit it using the VI, you will be able to see something called as connections and authentication, which will have listen address equal to localhost. That means um, this particular tutorial is not about defining what are the different parameters like, but this will give you a kind of glimpse of what is PostgreSQL.conf, how to modify it, where it exists, and what all can be done with this. So there is, in this particular section, connection and authentication, you have listen underscore address equal to localhost. By default, Postgre do not allow the remote connections. So it is equal to localhost. So if you have to allow remote connection, you need to change this value from localhost to the IP address of the server. In my case, the IP address of my system is 71.192.168.1.71. So in case I have to allow the remote IP address connection, so I will have to add the IP address of the server itself, where server is running, Postgres server is running. Port is 5432. Max connection is equal to 100 at this present time. So you can see on the right hand side of each parameter there is change requires restarts. If you try to restart, change the value of max connection from 100 to 200, you need to restart the server, sorry, the my Postgre instance. And let's move on to the next one, connection and authentication. Then you have something called as resource usage. So how much of resource you wanted to give to Postgre server. So by default, for our system where I have 2 GB of RAM, I have given 128 MB. So when you are tuning such parameters, shared buffer, you need to set to some minimum value, let's say 15 to 20% of the RAM. Then you need to gradually increase till the time you find the optimum usage of the RAM. So if you try to update any of the parameter like huge pages or shared buffer, it says the change requires restart. So you need to restart the change. But there are some parameters you will not see, like change requires restart, like work underscore mem is equal to 4 MB. So uh, uh, this is work area when some temporary rearrangement has to happen in the memory. So you can see it is some 64 KB, and as of now it is 4 MB. And if you have to increase the value, you do not need to. I think this can be done on the fly. The next one is val, which is write ahead log. That means whenever any change is made to the database, so before writing to the database, it has to be written to a file, which is a val log. So you have these replication parameters also mentioned in PostgreSQL.conf. And so you have sending servers, you have master server, you have standby server. We'll have a separate session for replication. In PostgreSQL.conf, you have something called as query tuning also. You can enable the hash join or index scan. So by default, they are on. If you wanted to turn it off, you can do that as well. So you have a lot of parameters, some 312 parameters we saw in PostgreSQL.conf. So based on your requirement, you can turn it on or off. Reporting and logging, like let's say where I wanted to record all what is happening, so you can put it in to where to log, then you have when to log and what to log. So you have all the flexibility available. Auto vacuum is one of the greatest feature in Postgres. So any unused space or any kind of maintenance activity happens by in this auto vacuum. So by default, it is enabled. So we have a separate session on auto vacuum. Client connection or defaults are available. Then you have lock management is also available, like what happens when the deadlock is the instance faces the deadlock situation, like how many locks per transaction it can support in particular point of time. Then you have version and platform compatibility. So this is somewhat related to your backward compatibility. Error handling, so when your instance suffers some kind of error, what it is going, what it's supposed to do, it is supposed to exit or restart, or what it has to do. Config file includes, so this will give you the location. So this option allows settings to be loaded from file other than the default PostgreSQL.conf. In case you wanted some non-default PostgreSQL.conf, so you can do it in config file includes. And that is it. So just a recap, what we saw is we did a small demo like how to find the location of PostgreSQL.conf, and then we saw if the context is postmaster, then in that case you have to restart your instance, and if you there are parameters which can be changed globally using alter system set command, and there are some parameters which requires restart. And when you say older system set, and if it requires a restart, it goes to PostgreSQL.conf auto file, and it is read when your instance is coming up. So the first one is to be read is PostgreSQL.conf, and that is the second one in that. And there are several other parameters which are available in PostgreSQL.conf. Let us see how it looks. So let's go to the data directory, ls-lrt, and this is PostgreSQL.conf. If I just say vi, if I wanted to add it, I'll have to do this. So this is PostgreSQL.conf. So the file consists of lines in the form name equal to value. So there is a parameter, and on the right hand side there will be a value. So it is mentioned over here that this file is read on server startup, and when the server receives a sign-up signal, if you added the file on a running system, you have to sign up the server for the changes to take place. Run pg underscore ctl reload or execute select pg underscore reload underscore conf. Some parameters which are marked below requires a server shutdown and restart to take place. So you can see there is one parameter section which is file location, like what should be the location of data directory, HBA file, ident file, external PID. Then you have connection and authentications. Listen address is very important if you have to enable remote connection. So I have mentioned the IP address. Port is by default this one. Max connection is 100. Super user reserved connection is 3. So this is under connection and authentication. Then you have the second parameter section, which is resource usage. Like you can mention the amount of the RAM which can be dedicated to shared buffer or work memory, and so on. And so there are a lot of parameters which you can do. Then you have val log parameter. So a lot of things are there in each section. Then you have replication section wherein you can once you have the replication set up, you can enable the parameters. So we'll have a separate session for this. Then you have something called as query tuning. So it is there is a great scope available in PostgreSQL.conf. Then you have reporting and logging, like where to log, what to log, and like rotation also is available. What, when, and where. So everything is available for your this thing. Then you have process title, like what should be the Postgre cluster name. Then you have statistics section, auto vacuum is there. Then you have client connection defaults. We are not discussing the individual components. Then you have log management. You have version and platform compatibility. Then you have error handling component. I'm just going through the different components which we have. So there are 312 parameters which are available. So, and uh, and it depends, like if parameter has postmaster attached with it, that means underscore pg underscore settings, then you have to restart the instance. Otherwise, you don't need to do so. So I hope it is going to help, and thanks for watching. Welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn how to use pg_hba.conf. So I have done some pre-work, so I have listed all the steps which we are going to perform for this particular pg_hba.conf. So first of all, let's understand what is pg_hba.conf. So it is a file which is available in the data directory on Postgre server, and it is known as Postgre host-based authentication file. And this is responsible for four things, like which host or which IP address are allowed to connect through a particular role, how the clients are authenticated, like they will be using some password or MD5 or some crypt, or and then which PostgreSQL username they can use, or with which role they will be able to log in, and which databases they can access. So all this information is mentioned in pg_hba.conf file. To demonstrate this, let's perform a small demo, and then we will go through all this theoretical part. So the demo which I have is I have two server. One is will be acting as a server where PostgreSQL 12 is running with the IP address 192.168.1.71, and another is 61, which is a client. So let me quickly log into the server, and what we are going to do in this demo is we'll log into the Postgre server. We will create a role with the name user2_remote. We'll give it a login access, and then with this role we will try to log in from the remote server, and we will see what all steps we have to take care when the this particular role is trying to connect from the remote server. So we will be doing two things, in since by default the Postgre do not allow remote access, so we will enable that access, and then we will mention the IP address of the remote server in our Postgre server so that it allows the access. So let's start. So I'm already logged in through the Mobile Extern, which is a GUI tool, and this can store your IP address, user ID, and password. Since this is a demo environment, so this is good to have it. So I'll just say sudo systemctl status PostgreSQL -12. So you can see the status is active and running. So just switch to PSQL. So I'm onto the command prompt. I'm going to create a user with this particular command. Create role, role name with login and then password. So just say /du and you can see the role. User2_role is created, which is having the uh, login access. It is not having cannot login, so it will be able to log in. Let's quit out of this prompt and then log into the remote server. From remote server, we will try to log in with the details. So the command to log in from the remote server is this one. So I'll just have to say psql-u, which is username. The user which we have created is user2_remote -w postgre, and this is the IP address of the server. The server is running on 1.71. Just press enter and feed in the password. So password is password. So this is saying that it is not going to accept the connection, and once the connection is accepted, you will have to, it will prompt for another one. So we will make two changes. One is uh, there is a file which is called as postgresql.conf. So this particular file, there is a parameter which we need to tweak, and the parameter name is local_address. By default, Postgre do not allow remote connection. So just to allow the remote connection, what we have to do is we have to remove the local host entry with the IP address of the server itself. So this will be removed with the IP address of the server itself, which is 192.168.1.71. When you make this change, you have to restart your service. So just make sure that you do that. So we'll save this. And then there is another file which is pg_hba.conf file. So what you have to do is in this we will mention the rule, like how the remote server will be able to access. So if you open this file, which is owned by Postgre and Postgre, so you scroll down and there is a section called as IPv4 local connection. So there are 5 entries which you have to mention. There is type, like we will say it is host based. Which databases you wanted to use, so we'll say all databases. Which user you wanted to connect with, so I'll say user2_remote. With which IP it is coming from, it is coming from 192.168.1.61. And then what authentication method it is using. So there are several. In our case, we will be using MD5 so that the password doesn't come in plain text. It will be encrypted, and we'll just add this line. So I have already added that line and just uncommented. The detail is first is host all, then the user ID, all, this is the database, all the databases, this is the user ID, this is the IP address, and this is the authentication method. So just save this. So we have made two changes, one in PostgreSQL.conf, where in the localhost is replaced with the IP address. In pg_hba.conf, we added the details of the remote host. And we need to restart the service of PostgreSQL because we have changed our parameter. So just restart it. Just check the status. The service is active and running. Now let's try to connect it from the remote host. You can see you are able to log in. You can see all the databases because you have mentioned all. You need access on all the databases. So now let's come back to the theoretical portion of this since we have done this demo. So the first thing is, what is pg_hba.conf? The pg_hba.conf is a Postgre host-based authentication which takes several parameters. So mainly it is 5 parameters. One is the host, another is the IP address of that host, then the which databases you wanted to access, and then the method using the password, peer, or trust, or reject. Now, if let's ask few questions and answer it ourselves. What is the usage of pg_hba.conf file? So this file is used for client authentication, which is available on the Postgres server, and this is for the client IP, username, and the database name authentication. It has a number of entries. Mainly there are 5 columns, which defines like which host, what IP address, which database, which user can access. What are the contents of the file? So it has a number of parameters, mainly 5 parameters. So it is all related to the particular host, user ID, and the database. And when is the pg_hba.conf file is read? So whenever an application requests a connection, the request will mention a Postgre user ID and password. In our case, it was test2 underscore remote. So when PostgreSQL receives a connection request, first of all, what it will do is it will check the pg_hba.conf file, which is Postgre host based authentication file, and it will verify that the machine details are available in that or not. So as soon as it finds the detail, it will either accept the connection or reject it. So it is just the connection. It will not give. It is not related to giving the access to the tables or other stuff. So next question is, do I need to restart the PostgreSQL post a role creation and access connection? So whenever you create a new role on a PostgreSQL server and a new connection is requested based on that created user ID or the role, you mention a matching entry in pg_hba.conf, then it checks whether that entry is available or not, and once it is verified, the access is granted. So you do not need to restart the PostgreSQL server, Postgres server every time you add an entry in pg_hba.conf. So what is the sequence of reading the elements in pg_hba.conf file? So it is like when a connection is requested, the Postgre will read one entry at a time from top to bottom. So if I show you this, this is my server, and uh, if you view this HB pg_hba.conf file, if we scroll down top to bottom, so it will be coming top to bottom. So in this case, as soon as it finds an entry, let's say I'm trying to connect through this IP address, if there is an entry available, so the access is granted. So you can give the host and then database, either it is all or the particular database name, or let's say there are 5 databases, so you can give let's say the 5 databases are A, B, C, D, and E. So I can mention A, comma B, comma C, comma D, or comma E. Or if there are n number of databases, you can put all the database names in a file, and you can mention the file location over here at the rate and the file location, so it will read from there. And you can mention the user ID over here. If it is more than one, then I think also that is possible. I have not tested, but this should be possible. Again, the concept of more user ID, uh, keeping in a file, you can use that. And then the IP address or the range of the IP address. In this case, /24, that means only first 3 will be constant, and this can be anything between 1 to 254, I believe. And this is the authentication way. The next one, which is very, very important, if you haven't, if you do not know like how to find the location of pg_hba.conf file onto the Postgres server, so you log into sudo su space hyphen Postgre. Let me clear this screen. And what I will say is PSQL, and then you have to mention show HBA underscore file. So this will tell you the location of HBA file. If you do not know this parameter name, then by default this is available in your data directory. If you have changed the data directory, you need to check this. So data underscore directory. So most of the time I keep it handy so that I can copy and paste. So this will be available in this particular location. If you don't know much about these commands, if you do not know if it is this is the first time, then you can use the Unix based as well. Or there is a direct command, so you can say psql-t-p format is equal to unaligned, and then you can say show hba underscore file. So it is like it will directly connect to PSQL and then give you the output. This is the file name. Or you can use the find command, which is the Unix command, and this will show you. It takes some time, so let it come out. Till that time, what we will do is we will go further. So this is a sample pg underscore hba.conf file. So there is one local section wherein the concept of Unix socket connection comes. So all the local users, they can be put over here and they will be able to connect. So by default, it is all users which are created, which try to connect from locally from the server. If it is remote, you have to put the entry in IPv4 local connections. Make sure that your PostgreSQL.conf file has the listen underscore addresses replaced from localhost to the IP address or the star in the previous version. And then you have to mention this particular entry, local host all the IP address, and then the subnet, and then the authentication method. If you wanted to enable all connections using IPv6, you have to mention this. And if you wanted to reject also, so there you can mention the IP address and mention reject. All right, so let's see an example of single host entry. So it is host, which we have mentioned in our case. Either you mention the database name or all the databases, you mention the username, the IP address, then the subnet. If it is like this, let's say the first three will be constant and this can change. So let's make 8 3s 24, and this is trust, not good, but let's make it MD5. This should not be suggested even. If there is a rejection entry, then you mention the details and particular IP address, fixed subnet, and then you mention reject. If it is script, then also it will look like this. If you wanted to mention about a small network, so just mention host. This is the database or the list of databases. Let's say template 1, 2, 3, 4, or at the rate file name, which consists of a number of databases, or username, or a number of users, and then 192.168.1.0. So 1 to 254 IP address, so they can access, or you can, uh, or let's say you these two will remain constant, and anything in here in between 1 to 254 and here also, so you have a bigger network. And if it is like this, only this will be constant and this will keep on changing. So this is how, so small networking part, but most of the time you will have something like this, only these two might change. So just a recap of what we have done. We did a demo where there were two server, one was server and another was client. We created a user with the name user2 underscore remote. Then we try to log in from the remote server using this particular command. This is my remote server. So initially when we tried connecting psql-u username w database name -h, the IP address of the server where Postgre is running, we got this connection refused because initially it was allowing only the local connection. So you have to remove that local connection with the IP address of the server itself. Make sure you are not adding the entry of the client in postgresql.conf, which is the server parameter file. And then we made two changes in two files. One is postgresql.conf and another was pg_hba.conf, wherein we added the details of the server, the client where it is running. So we mentioned it like uh, host name. So let me quickly show you this. So the entry which we added is like this. Host, I wanted to access all databases with this particular user ID and this IP address range, and the authentication method is MD5. So this is how this, so this is very important file, because every time you try to make some changes, you create a new user, you create a new role, and it is trying to connect from a particular IP address, then you need to mention those details over here. And so PostgreSQL.conf and pg_hba.conf, they go hand by hand. So the first file which you need, if it is your first time, the PostgreSQL.conf, you change it from localhost to the IP address of the server, or replace it with a star if it is 9 or the older versions. And then you work on hba.conf file, wherein you need to mention all the details related to the remote environment role, which databases, and the IP address. I hope this is more than enough, and in another tutorial you can see more about PostgreSQL.conf. I hope this is going to help, and thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is Postgre tablespace. So this is an introduction to the Postgre tablespace. So if we say in the layman language, we'll say tablespace is a space or a storage location where all the tables or objects occupying the storage are stored. So what is table space? So it is a location on the disk, whether we are talking about the file system on the Linux or drive on Windows system. So this is the location where Postgre stores data files, and how Postgre is letting the instance know where it has to store the file, that is referred in the table space. So what table space actually does, it map a logical name to a physical location on the disk. So in the demo, we will see the logical name and where does it corresponds to. So you would already be knowing that there is something called as $PG data, which denotes to the data directory location in Postgre, where by default all the data files or objects occupying the storage are stored. So when we talk about the table spaces are nothing. They are just a logical name which corresponds to a physical location on the disk. Let's say you have installed your Postgre instance on the on database in Windows system. Then in your C drive at a particular location, you will have the data files located. So by default, there are two kinds of table spaces mentioned in Postgre. One is known as the PG default, which stores all the user's data will be stored over there, and PG_global, where all the global data is stored. So when an instance is created, you have two table spaces. One is PG default and another is PG global. Default means the one where user data is stored, and global means where all the global data is stored. So it's good to ask, what is the advantage of using table spaces? Let's say I wanted to create a new table space. So does it mean something? So by default in Linux, the data files are located in slash var lib postgre. Let's say the version is 12 and slash data at this particular location. But the storage in slash var, which is the default location data directory, is not unlimited. And if you wanted to create a new file system, if you are unable to create extend this storage, and if you wanted to use a new file system, and in that case you have to create a new table space, and you have to point that particular location to the new file system or drive. Or there may be a possibility that you have high performing storage and you create a new table space and you put your high performing objects which requires the high performance in that table space, and it is good for the performance of PostgreSQL instance. So what is the default storage in PostgreSQL? So when you install your Postgre, let's say on RHEL or Windows. So in Windows, everything will be done automatically by the run installer. But in Linux system, when you install the binary, then it asks you to initialize the database. So you initialize the database using pg underscore ctl hyphen d, the data directory location if it is non-default, and initdb. So you start the instance following the initialization. And what happens during this course of action, there is a location which is created, which is called $pg data, wherein all the data or data files related to PostgreSQL is stored. So by default, there are two table spaces which are created when you install a new instance. One is pg underscore global, which refers to the global system catalog uh, catalog files, or what do you say, uh, the shared system catalogs. Or there is something called as pg underscore default, where your user data is created. So we are more interested in pg underscore default because your user data will be stored over here. And how do we create a new table space? For creating a new table space, you will have to log in into Postgre command prompt and just say create table space name, location, and this is the physical location on your Linux system or your Windows system. And on the Postgre prompt, if you say slash db plus, so this will show you all the table spaces available. So how do we create the object in a new table space? So you simply say, let's create a new database, create database db1. And if you don't want to mention the default table space, and if you mention a new table space which you have created, you simply say create database name, which is more than sufficient. And if you wanted to have these database created in a new table space, you just say table space and table space name. So you switch to the new database, and then any table which you create inside that database will be automatically created in the new table space. That means it will go to the new file system or the location which you have mentioned. Otherwise, what you can do when you create the tables using create table command, you can mention the table space name. So either you say table space, new table space, or table space, the existing table space, which is pg underscore default. So it works this way. So now we'll see the demo, how it works. So we will initialize instance, and once the initialization is done, we will check what is pg data, which we have already discussed in the previous tutorial. And then we will see what is postgre table space, what is the default table space, and then we will see the location of the default table space. We will create a new table space, the objects in the new table space, then we'll move objects from one table space to another, and then we will see on the instance label how to change the default table space. So this is what we are going to do on Postgre demo. So this is the list of steps which we are going to perform. And let me close the PowerPoint presentation. And this is my Linux box. I'm already logged in as MOBA Xterm tool. So I'll just say sudo su hyphen postgre. Sorry. Let's clear the screen. And what we are going to do is either you create a new instance or you initialize the existing one. So we are going to initialize the existing one. We will say pgctl hyphen d data init dv. So let's do this. So, okay, let me do one thing. Let me stop the instance, or let's create a new instance. I'll just say mkdir-p and create this location. And then let's instantiate it. pgctl-d, the directory location, so that a new instance is created in a particular data directory, and initdb. Oops. It is also not empty. Let's create another one. Let's say 2. Create this directory. Done. Then start do the initialization. This is also existing, so let me see what all I have done. Instance 1, instance 2 is also available. Let's create instance 3. mkdir and then initialize the database. You can see that fixing permission on existing directory. This is data directory. So this is how you create a new instance. So let's initiate or start this particular instance. This is starting. This is how do you start the instance. So what I will do is I'm not going to use this. This is just how do you create a new instance. I'm going to the existing one, sudo system ctl status PostgreSQL -12, and you can see there is something called as pg data for the default instance. So I'll go to cd $pg data. If I say ls-lrt, you can see n number of files are over here. And then what I'm going to do is inside, if you see the content of the files or the folders or the subdirectories under this, you will be able to see these many number of files in PG data, right? So by default, when you create the objects, where does it go? It goes into PG data. So this will go in this particular location. So over a period of time, this particular location will keep on occupying more and more storage as the user data is inserted, created, or it is done. So how it happens? So it happens due to the what do you say, the table spaces. So let me log into um, to the browser using the uh, PG admin 4 tool. This is the IP address of my server 192.168.1.61. So just click it and you will be able to see something called as table spaces. So by default, these are the two table spaces which are created, PG underscore default. So you can see that I have a database DVD rental. So DVD rental will find the storage in PG underscore default, whether it is sequences, indexes, or there will be the tables also. So these are the tables. So you can see that these are existing in PG underscore default, and when you see the PG underscore global table space, you will see the catalog related tables or the indexes. And table space in actual uh, uh, corresponds to what you say as the PG data location. So PG data, PG underscore global table space is used for shared system catalogs, and PG underscore default is for default table space. So this is how it works. Let's create a new table space. I'll say TBS2 MKD. The first step which we have to do is we have to create a directory location or folder location in Windows. So mkdir-p, I have created that. Then what we have to do, we'll have to log in as psql, and then we have to fire the command. So by default, when you say slash db plus, this shows you all the table spaces which are existing as of now. So I already have two more table spaces which I created in another demo. So these are the two table spaces which are created by default. And if the location is not mentioned, that means it is corresponding to PG data, which is the default data directory location. If you have changed the data directory location, it must show it over here. So the next step is we have to create a new table space. So the command is create table space name, and the physical location on the file system. So you can see there is a relationship between the location and the table space name. Table space created, just say slash db plus, and this will show you the new table space which we have created. So this is the new table space tbs2, and this is corresponding to this physical location. So what we will do next is there is something called as pg underscore table space location. uh, pwd, I'm inside cd data. This is your default data directory, and there is something called as pg underscore table space. If you go inside that and say ls-ltr, this will show you a symbolic link. In our case, this is the object id, oid, unique object id for the new table space. The Whenever you create a new object in a new table space, it goes to postgre slash data slash tbs2. So all the information is still there in pg data and in pg underscore table space. So it has created the link automatically. So now let's create the object. So we'll say create, we have already created the table space, uh, and now let's create a database. Create database db2 table space tbs2, which is already we have it. Oops, I entered the wrong password. All right, just say create database name and table space name. So that means this particular database will be created in new table space. So any object which is created inside this one will be automatically uh, created in new table space. So that's obvious. So let's switch to the new database, which is db2, and now let's create the table. When we say create table tab 1, so it is going to create that particular table in your new table space. Let's say create table tab 2, and if you mention the table space name, then also it is going to create in the new table space. Or if you wanted to mention the table space name, it will. So there is nothing great in this. You just mention where you wanted to create it. Let's say I wanted to create a new table space in default new table in default table space, so I can do that. So the problematic part is when you have to mention the table space name. So how can we do that? Can we move the objects from one table space to another? We can do that. Or can we alter the uh, change the table space from one to another? We can do all of that. So if I just say alter table all in table space, and we set it to default table space, it is possible. We can do that. But whenever you do all this operation, there will be a lock on the table and nobody will be able to use that. What if I wanted to utilize the new table space? So any new user who comes in wanted to use the new table space. So let's do a demo for that. So let's create a new location, mkdir-p postgres/data new table space 2, and we'll say the table space name is tbs 2, and this is the location, and we are going to create a table in new table space. So this is the time taking process, right? We create a folder. This is an administrator part, so that has to be done without any you cannot skip this step. The second is when you create, you have to create the location. You have to create the table space with the new location. And if the application team wanted to create the table inside the new table space, they have to mention the table space name. So create table, table name, table space. But this is problematic. Let's create a new table because this table already exists. Oh, this is also existing. So it is create table, table name, table space, new table space name. Yes. So this is done. But it is always very problematic when you have to mention this. So can we do something so that the default table space is changed? So we can say set default table space to uh, the new table space name. So we can set this. Let's just say show default table space. So there is one default table space. And let's change the default table space to the one which we have just created. You can see the default table space is changed from pg underscore default to so any user now who is going to create the data, uh, either table indexes or anything, so it is going to find the storage in new location, which is this location, and which is corresponding to this particular table space. Since we have already mentioned it that default table space is this, so any object which is created will be created in this particular table space. So if I simply say uh, create table foo3, then it is going to create the table into new table space. And if you wanted to cross verify, what you can do is just refresh it. You will be able to see the new table space and the objects will be here. So still it is showing fetching dependent information from the server. So this is the foo2 and the 3 which we have created. So this time we have created foo3. So by default it has gone to the new table space. So is there a way we can so the problem will be when you have to take the backup. So the command is already mentioned, pg underscore base backup, which we have already seen in previous tutorial. You just mentioned the format, and you have to mention the location of your new table space which you have, the additional table space which you have to create. So you have to just make a note of that. And finally, why is table space used for? So table space just used so when your database is growing, so you wanted to go to a new location, so you mention it using the new table space. Or it may be possible that you have a high IOPS or SSD disk which you wanted to use for your objects, so you create a new table space and move your all objects over there. So just a recap, what we have done. We initialized an instance, and then we saw what is PG data. PG data is nothing but all the data in your instance goes to this particular location, which corresponds to the default table space. Default table space has two components. So by default, when an instance is created, you have two table spaces, pg underscore default, pg underscore global. Pg underscore default is a table space wherein user data is stored, and pg underscore global where global data is stored, which is related to the instance. And then we have seen what is the default table space location. Default table space location is pg data, and then we created a new table space. So you create a new physical location using mkdir, then you create the table space, then you mention the location, so it will be linked. Then you say slash db plus, so this will show you the all the table spaces. And when you go to cd2 data and pg underscore table space, this will show you the symbolic link. That means all the information is still in pg data, pg underscore table space, and new location will be mentioned over there. And that is a kind of symbolic link. So you can see we created this particular tbs2. This is the unique object id, and this is the new location, and it is available in uh, pg data inside pg underscore table space directory. Then we created a new table space, and you can create the table ending with the table space name. Either it is pg underscore default or the new table spaces, or if you wanted to set the table space parameter at the instance level, you just say set default table space and table space name, so that the new objects which are created, they will be created inside the new table space. And how do we back up the additional table spaces? You can use pg underscore base backup. You provide the table space mapping, and that is it. And finally, why is table space used for? Uh, Table space is actually used when your database is growing and you wanted to go to a new location, new physical location on the server. And so you bind the logical name with the physical name. The logical name is your table space, and physical name is the location on the server. And there may be a scenario also wherein you wanted to keep the frequently accessed indexes or the tables into that particular high performing disk, and you create a new table space and you move all the objects over there. So this is all about the table spaces in general. So I think this is more than enough. I hope you have learned a lot about Tablespaces in Postgre, and see you in another video. And thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is PostgreSQL schema. So in this slide, we will learn what is Postgre schema. So if you have already installed Postgre SQL software either on Linux or Windows system, you will know that by default there will be one instance. If you wanted to have more than one instance, you can do that. So at the top label, you have instance, and in the instance, you have databases. So you can say that a PostgreSQL database cluster contains one or more named databases. And in turn, a database can have one or more objects which are called as schemas. What is a schema? Schemas in turn can have tables or different types of objects, or it is just a container which can have different types of objects in it. So if I say in a particular database, if I am connected to, I can create multiple schema. Let's say I create a schema 1, I can create a schema 2, or n number of schemas I can contain. So what will happen have over there? Let's say I have created a table which is called as actor in schema 1 and another table with the same name in another schema. So let's say the name is again actor in schema, so schema 2. So two schemas with different name, schema 1 and schema 2, but same table name, which is actor. So it is good to organize the tables in different schemas. And so if you talk about a schema, is it synonymous to anything? So it is something like directory or folder at the operating system level. There is nothing more than that. In that folder, there will be different objects like tables or views, or what do you say, the functions, etc. So this is a brief introduction of a schema. Schema is nothing, just a logical container which can have different tables and data types. So why do we need to use a schema? Is it something new? So no, it is not something new. So a schema allows you to organize database objects. Let's say I have a database with the name DVD rental, and if I have two schemas, let's say schema 1 and schema 2, and I have a one table which is known as actor. If I wanted to access it through two different schemas, I can do that. So it is easier to organize the objects in the schema. And if I wanted to take a backup of the particular schema, if I have to restore it, then it is very easy to do that. And organization in particular schema will be easier. What I can do is I can restrict the user to work onto a particular schema, and I can say you don't have access on other schema. So it is good to have schemas in place. It is something like mandatory. You should use it. There is something called as public schema when we talk about Postgre. Public doesn't mean that it is available for entire public or all the users which are connected to the database. Sorry, I mean to the to the instance. So when you when you create a database in Postgre, by default there will be a schema which is the only schema present which is known as public. That means if you have not created any user-defined schema, then all the objects which you create will be there in the public schema. So any uh, role which has access to the database, or user which has access to the database, can create the table in public schema. And public schema is available by default in all the databases which you create, and that is the only schema which is available. So there is something called as search path. What happens if I say, if I'm connected to DVD rental, let's say my database name is DVD rental, and if I say select star from actor, so in which schema it is going to look for. So there is something called as public schema. So by default, it is going to look into the public schema. If you say show search path, then it will search either in user dollar. There is something called as user dollar, and the other one is public. So if the schema name is equal to the username, then the object will be searched in that particular schema. If not, then it will be searched in the public schema. So what is the building block of Postgres? So we have a PostgreSQL cluster. That means there will be one set of software. Let's say Postgre 12 I have installed. So by default, there will be one instance. If I wanted to create another instance, then I can do that. So each instance in Postgre will have its own set of background processes plus memory area, and in each instance you can create different databases, and each database will have the container which is called as schema, and schema can contain different types of objects. So this is the hierarchy. So you have Postgre instance or the cluster, you have inside the cluster or instance you have databases, inside databases you have schemas, under schemas you have objects. It is just like folders. That's it. So let's come back to the demo. So I'll show you I'm already connected to uh, PG-admin 4. This is the IP address of my server 192.168.1.61. I have 6 databases. I'm going to use DVD rental. So if you uh, click this, you will be able to see different options. And by default, there is one schema which is with the name public. It doesn't mean that it is available for the entire users. No, it is not like that. So by default, when you create or select the object, it comes from the public schema. So what we will do is um, so as of now, there is only one schema. Let's create two more schemas. I'll create two schema with the name schema 1 and other again with the same schema 2 name, schema 2. Okay, and what I'm going to do is now um, either you can use the command prompt or pgadmin 4, and let's do. Okay, I'm already connected over here. So I created two schema, schema 1 and schema 2. And in my public schema, there is a table called as actor. So if I simply fire one statement like select star from actor. Okay, let me do one thing. This is my command prompt of 192.168.1.61. So I'm connected as mobile xterm. So what I will do is I'm connected as Postgres user. So I just say PSQL. I'm connected to Postgre prompt. So if I say uh, switch to database, the databases which I have is these many. So I wanted to connect to DVD rental. I'm connected to DVD rental. And if I say select star from actor, so I'll be able to see the data, right? So this is my actor table, which is available in public schema, and I have created two more schema, schema 1 and schema 2. So what I'm going to do is I'm going to create the structure in these two schemas for our demo. By default, I click this icon. So, okay, let's go to the query editor. I'll go to schema 1. Uh, Expand this. You can see the public schema. Just go to schema 1 and say um, query tool. And I will create a blank table with the name actor. Just execute this. So this is a blank table. All right. Create another table in the schema 2. Let's create that as well. All right. So if I have to select the data from individual tables, so what I will have to do is I will say, if I say select star from actor, by default it comes from the uh, it comes from your public schema. And if I have to say the specific schema, I have to say schema 1 dot actor. So I'll say select star from schema 1 dot actor. So you can see that we created just a blank table and there is no row. And similarly, we did it for the schema 2 also. If I say schema 2 dot actor, so it is coming as again blank. There is no data because we created the structure only. And if I say select star from actor, it it displays the data from public schema with the table actor. So how this all is happening, we will see. And if you wanted to drop a schema, just say drop schema name. And if there is any object, you will have to say drop schema name and cascade. There is something called as schema search path. So when I'm saying select star from actor or select star from schema 1 dot actor, how it is actually doing, or if I'm just saying select star from actor, is there any parameter which is deciding like from where it has to pick the information? So there is something called as search path. So if we go to PSQL and say show search path, it will show the two output. One is $user and another is public. That means uh, the user which is connected. So by I'm connected through the Postgre user. So when I am going to create any object or select any object inside this particular user, by default it will look for Postgre user schema. If it is present, it is going to create object or select object from there. If that particular schema is not present, then it will go to public. So if I, oops, again I click this. So this is my DVD rental database. So I have three schemas. By default, I'm connected through the Postgre user. If if the schema is not present with that name, it will look for public. Why? Because that thing has been mentioned in search path. Either the schema should available with the username, or the second option is public. So if the first option is not available, it is going to look for the public schema. What if I wanted to say select star from actor and it picks the information from schema dot actor? So what we have to do is we have to tell to the instance, you go and look into schema 1. So we will have to change the settings. How do we do that? We can, if I say show search path, we have user public. So instead of user, by default, I wanted it to come from schema 1. So I have to set that. So we'll say set search path to schema 1, comma public. So that means it will first look for schema 1. If that is available, it is going to show the data from there. Let's verify it. Yes. And if I say select star from actor, So I have a blank table available in schema one, so it should show that. So you can see that. And if I have to search from the public schema, I have to explicitly mention select star from public dot actor. So you can see that. So how everything is being controlled? Everything is being controlled through search path. And you have some schema and privileges as well. So by default, uh, users do not have access into the schemas which they do not own. That is true. You have to give the permission. So what is the usage pattern? You should issue revoke create on public schema from public. That means you should not allow any user to create or select the object from there. Selection is fine. That's not a problem. If you wanted them to create the object inside that, that should not be allowed. What if there are multiple users and they wanted to create the object with the same name? So it is going to be a problem. So what you should do is you should remove the public schema from default search path. So what we did right now is we changed it to from user dollar comma public to schema one comma public. So you should do similar for the application user, right? Remove the public schema from default search path by issuing alter role all set search path equal to. So it is a good practice to have the schema name with the same name so that they can create the objects over there. So the conclusion of this is you should not use the public schema. So just a recap of what we did is we learned what is a schema. Schema is just a kind of folder or container which contains objects which you can see in. Um, Sorry, I clicked again. So I have a database which. Oops. Where is the screen? Okay. So I have a database DVD rental. Inside DVD rental, I created by default there is one public schema. So everyone will be able to. So those who have access to this particular DVD rental database can select from public schema, and they will be able to create the objects over there. What you should do is you should create the named schema where in the application owner can create their objects, or they are the owner of this schema. And how to modify that? You should change the search path so that by default it doesn't go if that user dollar is not available. That means if the schema name which is not equal to the connected user is available, that will go to public. So you should remove that. In that way you can organize your objects better. And if you just right click on one of the schema, then you can see you can do a lot of things. You can create the script, you can backup, you can restore, you can grant the wizard, you can search objects. There are a lot of things you can do with that. So schema is a great object in your Postgre, and you should use it wisely. I hope this is going to help, and thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn about Postgre cluster. So okay, so what is a Postgre cluster? So when we say cluster, it means a number of nodes which are connected together and they are serving as one unit, or multiple database instance which are connected together and called as a cluster. But this is not that cluster in PostgreSQL. When we say Postgre cluster, it means it is a collection of databases which are managed by a single Postgre instance. So that instance will have its own background process, and it will have its own PG data. So what are the different components of the term cluster in Postgres? So we have something called as data directory. So let's say when you install Postgre on Linux system or on let's say Windows system, there is something called as data directory wherein all the files which is related to the database, tables and other logical entities are created, and they are specific to that particular instance. By default, we create only one instance if there is no need to create another instance. So that data directory is being managed by the Postgre processes. So it manages all the data directory files and interfaces of those contents. So when we say cluster, it means two things: combination of data directory and Postgre process. What is the use of having one more cluster when you already have one instance? So you can say it as it is a temporary database which you can create outside of the existing instance. You can make any changes in the new PG data directory, let's say postgresql.conf or pg underscore hba dot conf file, and that is separate from the default instance which you have installed. Or there is another purpose. You can have a different version of the Postgre at the same time. So you create one more instance, you test the environment, or you can have multiple versions, or you can create the database in the new instance, or in layman language we'll say having one more instance with its own data and the background process. So how can we create a new instance? So to create a new instance, you have to create a new data directory for the cluster. So you log into your existing cluster. Let's say in my case, it is a Linux system. So I'll say sudo su hyphen postgre. You can check the current location of PG data, create a new location, and then you initialize that particular location using initdb and the new data directory location. Once the instance is instantiated, you have to configure the cluster. By default, in the existing cluster, you will have the port 5432 active. So you cannot use the same port for the new instance. So you have to change the port to a new what do you number. So instead of 5432, let's say I'm going to use 5433 or any other. I need to change the Unix socket directory from existing. The current one will be your var run PostgreSQL, and let's say create a new location, and your Unix socket, which is required for connection from the same host, that will be used. Then you start the Postgres server once the initialization, and you have changed the parameter port and Unix socket underscore directory in postgresql.conf. You initialize it using pgctl-d, give the location of new data directory and log file, that is optional, or you just say start. Then you can check whether your new instance has come up with the new processes or not using ps-xf. So that will show you the tree structure with the postmaster at the base and other processes following that. Then once your new instance is instantiated, you can connect to that using psql-h localhost, new port, and the super user, which is Postgre. If you have to stop it, you just say pgctl-d, the location of the data directory, and if you have to give the log file name, you give it, then stop. If you have to reload, if let's say you have done some changes, which then you have to reload it, just say pgctl-d, the location of new directory, and reload. So it's very simple. pgctl location of new directory, either you say start, stop, or reload. Then we are going to perform a demo on a Linux environment. So let me take you through that. So I've listed all the steps. So I have a IP address 192. So the IP address of my host is 192.168.1.61. Operating system is 7.5 Linux, and Postgre, which is already installed with one instance, is Postgre 12. So we are going to log into that. So this is I'm logged in as root. So let's say the first step, let's say just switch the user to Postgre. So now I'm logged in as Postgre. Now just say for the existing setup, just say where is my existing data files. So echo pg data. Just go to this location and you will see these many files. And it has its own background processes as well. So you can just say psxf. So this is my current setup with one instance. So you can see postmaster is there, then these are the rest of the background processes. Now what we are going to do, we are going to create a new cluster with the new location of the data file. So what I'm going to do is I'm going to create a new file uh, wherein wherein we will keep all the data files. So let's create it in this location. Let me log in as root, and we will say mkdir, and we will create a data directory instance 2. I think I sudo su space minus postgre. This data directory is already owned by postgre user ls-ld, and let's say check the permission. So it is already owned by Postgre. Let's create this directory instance 2, wherein we are going to keep our data files. So this is created, and along with that, what we will do to keep the what do you say um, uh, the the socket file, we will keep will create one location. So we'll create one location like um, mkdir-p home instance 2. Just give the ownership to Postgre to this particular file wherein the socket file can be created. So we have done that. Now let's start the first thing which we will do is we have created the directory, then we will say initialize db and the directory location, and everything we are going to do as Postgre user. So initdb and the new data directory location. So you can see the file belonging to this database will be owned by the user Postgre. Database cluster is getting created. The user will also own the server processes and fixing permission on existing directory, creating subdirectory. So it is going to create all the files which were there in the existing cluster. Now it is saying if you have to start the cluster, you have to use postgre-d or pgctl-d command, directory location and the log file name, and followed by either start, stop, or reload. That three things you have it. Now let's create the Postgre cluster. Configuring that means we have to change the two entries. One is the port number and another is the socket directory location. So we'll say vi slash postgresql.conf, and we have to change two parameters. One is the port, because we cannot use the same port. This is already in used by the existing instance. So let's change it to 54333, and we will give the Unix socket directory as the new directory wherein the socket file will be created, and this was /home/ uh, and we created with the name uh, /home instance 2. So let's create put this. We have done this. Now we have to restart. First of all, we have to start the instance for the first time. So we'll say starting Postgres server. So we'll say pgctl-d and followed by the directory location, then log file, that's optional, and you can say just start. So starting, so this will start within a couple of seconds, and we will check using ps space xf. So if you execute this, you will see one is with my new location, new data directory. So this is my new data directory, and this was the old data directory. So these set of background processes for old instance, and this is for my new instance. So we have created one more instance. Now how to connect with that? So we will say psql-h localhost-p, port number is 5433, and the user is Postgre. Just execute this, and we are logged in to the new instance. Just quit out of this, and we will see one more command, how to stop the server. To stop the server, everything remains same. You just have to replace your so we'll say pgctl-d directory location where all the data files are there, then -l log file name. If you want to give, then stop, just say stop, and it is going to you can see that server is stopped. If you say ps if you try to connect to new instance, it is showing that there is some problem. The problem is it has been down. And if you just say psxf, it will show you that the background processes are obviously down for new instance. This is the old instance. And in case you have to start it again, just say start pgctl-d directory location and start. You start it, it is starting. And then finally, if you have to reload, uh, you made some changes, and if you have to reload it, then just say pgctl-d directory name -l log name, then reload. So signaled, and it is done. You can see our background processes for new Postgre is available now. So this is how we create a new instance. So just a recap. We create a new directory where the data file will go. The data file will go to this location. Then you just say initdb and the new location. Then you modify port number and Unix socket directory. Then you start the instance using pgctl-d directory location, and then you have to check the process has came up or not, psxf. Then you can try to log in psql-h localhost-p port number and the username. And this is how we create a new instance on Postgre. I hope this is going to help, and thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is a user, role, and a group in PostgreSQL. So the agenda of this tutorial is what is a user or a role in Postgre, what is public schema, what is a search path, and how do we revoke public from a role, how do we create a read-only role or read-write role, and how do we create a role, and then how do we grant privileges to the user which is created. The first one is the users and roles. So what is a user and role in Postgre? When we say create user in Postgre, that means it is equivalent to create role plus login permission. That means the only difference between user and the role is user is able to log in, but the role will not be able to log in. And the role has its own advantage. So if I say a SQL statement to create the PostgreSQL user, so I'll just say create user, username, then with password, and I'll give the password. If I have to create the same user with the create role SQL statement, I'll say create role, role name, and the only additional thing which I have to add is with login. And then we need to give the password, and that's it. So in Postgre, create user is equal to create role plus login permissions. So by default, all the new users and roles, they inherit the permission from the public role, and we'll see how it plays an important role. So what is a public schema and public role? So whenever you create a new database, let's say you created a new database, DB1, then by default, when you check the schemas which are available in that particular database, so you will see a schema with the name public. That means a user who has access to this particular database will be able to select or create the objects in that particular schema. So it is by default, the design is like that. So all the new users and roles, they have the default access to the public role, and they can create the objects in the public schema, which is not good. Then what is the search path? If I'm connected to a database, let's say, which is called as DVD rental, and if I say select a star from actor, actor is one of the table, and if I don't give the fully qualified name, then how Postgre will come to know like from which schema it has to pick the information. So that information is mentioned in something which is called as a parameter search path. If you log into Postgre prompt and say search path, show search path, it will show you two values. One is $user, another is public. Let's say if I'm connected to Postgre user on Postgre server, then by default, when you fire any query, it will search for a schema which is equivalent to the name of the user which is logged in. Let's say then it will look for that particular user. So by default, a schema with the same name will not be present. What is present is a public schema. So any user who is connected to that particular database will be able to see the objects or create the objects in the public schema. So as I mentioned, a DVD rental database, if I am just saying select a star from actor, then it will search, and I'm logged in through the Postgre. So it will try to look for the schema, which is equivalent to the database username, which is not the case. So it will look the information in public schema. So instead of saying select a star from public uh, dot actor, I'll simply say select a star from actor. So it is going to search from the public. If you have a schema with the name, let's say Postgre, and your object is lying over there, then it will look into that and it will display the result. This value can be changed. You can change the schema name so that by default it will look into this. So that's the importance of the search path. And it plays a very important role. What you should do about the public schema, you should revoke any creation of object onto the public schema, because if a number of users are using that particular database, and then it may be a messy task. So you should remove the create on schema public from the public, and you should also revoke all on database from public so that anybody cannot use that particular one. How do we create a role? Create role is, it's very simple. It's, you say create role, role name, and to that particular role, what you can do is, let's say I have an application. I wanted to create a read-only a role for some of the tables. So I can create the role, then I can say grant connect on that particular database. So my database in this case is DVD rental. Then I can give access to this particular role, and that particular role can use the app schema if I have created a schema with the name. So you can do a lot of things with the role, and finally this role can be granted to the application user or the user which you have created. Also, what we can do is we can grant any kind of, let's say, select, insert, update, delete, whatever you wanted to do. But as the name suggests, it is a read-only schema. So I'm just going to give select on all the tables, or a table like actor or film to that particular role. Or what also you can do is you can give all table access on that particular schema to that particular role. So you created a blank role, you gave it connect access to the particular database, then you said like you use particular schema, then you gave select access on n number of tables, and this way it is very useful. So you create a role, and then how do we create a database user? So you simply say create user, username, then with password and password name. And finally, you can grant the role to the user. So any user who is joining that application, so any user in that application group, you can grant the role. So it is very convenient. So any changes which is happening to the app underscore read only will be applicable to all the users. They will be impacted. Any table which is added or removed, the impact will be on the role, and the role is finally granted to the user. And now there is a demo which is following up. So this is the demo. So let me close this presentation. And this is the demo. I have listed all the steps in the notepad, and we'll perform this either on the. So I'm connected through MobiXRAM on my server, which is on a Linux server 192.168.1.61, and I'm connected through the Postgre user, which is having the sudo access on this. So what I'm going to do is, so what we saw earlier is um, we are going to create a user, and we'll see how it is different from the role. So we say create user is equal to create role plus the login permission. So I'm just going to create a user. Let's name it as create user app user one with password, which is equal to the password. Not a good practice, but this is a demo, so we are using this. This is the wrong password. The role is created. You can see the user is created app user. So where is the app user one? So this is the app user one, and there is no attributes, cannot log in. That means it is able to log in. And that is the only difference between user and the role. Roles cannot connect to the, it's not able to log in, but uh, uh, user is able to do that. If I create a role, let's say app user role one, and if I say with login, then it is equivalent to the create user statement. So that is what we discussed in the first slide. Create user is, it's already existing. So let's create another one, app role 2. So if I say /du, you will be able to see app role 2, and it is able to log in. Next one is what is a public schema and public role. They just to showcase this, I'll log into the PG admin GUI tool, and I'll connect to my database, which is on Linux environment, and I'll connect to the database, which is DVD rental. So here we go with the DVD rental. And what happens? Let me delete the role which I have created. Okay, so I have a database with the name DVD rental, and when I created it, it was a blank database. So whenever you create a database, you get a schema which is called as the name public. That means any user who is having the access on this particular database will be able to use public schema. That means any object which is created will go into this. Let's say if I say I'm connected through the Postgre user in DVD rental database, and if I say create table A, so that table will be created in public schema. So that's the way. If you wanted to use a specific schema for the particular user, you need to create using the create schema command. So we'll see right away how to use that. Search path. So I'm connected as Postgre user, and let's see how many databases we have. Let's go to DVD rental, and I'm switched on to the DVD rental database. If I say let me see the data tables we have. We have actor table, and it is there in the public schema. If I say select star from actor, or select count star from actor, I don't want to display the entire details onto the screen. I'll be able to get the details. But how Postgre is knowing, how the server is knowing from which schema it has to pick it up. So I'm connected to the DVD rental database, and there is only one schema, which is public schema. And there is something called as search path. If I say show search path, I'll be able to see two things. One is $user and another is public. So by default, if a user is connected, let's say my username is app user, then it will look for the schema whose name is equivalent to the user which is connected. If that is not present, it will look for the object in the public schema. So either I say select count star from actor, or if I give fully qualified name, which is schema name dot uh, the table name, it will display the same item. So if I just wanted to omit using the schema name, I need to mention the value in search path, and that can be set. All right. What we will do is we will do a small demo. We will, as a best practice, we will revoke privileges from the public role. So let's do that. So we'll say revoke create on schema public from public, and revoke all on database DVD rental from. Just in this demo, what we are doing is we are using DVD rental as the database. I'll go to the PG admin, and we will do it over there. So let me connect to DVD rental. Then I say query tool, so it will open a query editor, and we will execute all the statements from there. All right. So what I'm saying is we will revoke creator. So by default, nobody will be able to use that schema. And on all the database DVD rental, so that will also be revoked. So just execute this, either F5 or execute, both will work. Okay. This is done. Now what we are going to do is we are going to create a role which is app read only. Then create role name. Then we are going to say uh, it is going to connect to the database DVD rental. Then we are going to create a schema, app schema. Then we are saying just use that particular schema, and then we are going to select all tables in that particular schema, and that will be granted to that particular role. Let us create this particular role. We use the command prompt or the GUI tool, but it is good to watch it over here. So create role, then connect privilege, then create a schema, then grant usage on the schema, and then all the tables in that particular schema will be given the select access to that particular role, and that's it. Role already exists, so let me drop the role. So let's drop it, and then we'll execute it. Okay, so there are, let me change it instead of, so we'll say, we'll create a new role, which is app read and only underscore one. We'll say replace all, and we are going to use this. And we are using PG admin 4. I'm just clearing the screen, and we are creating a new role. It's very, very easy. There is nothing tricky in this. So it is displaying the last message. So this is completed. Now we are going to create a read write role. Here what we are saying is in read only role we gave only the select access. Here what we are going to say, we are going to give insert update read on all the tables in that particular schema. So let's create role read write. Let me see if that role is available or it is not. Okay. So read write. Okay, it is not. So let's execute this. So we are going to create a role read write, then it is giving the connect access on DVD rental. Then we are going to create a schema, app schema, which is already created. And you can use the name according to your requirement, and we'll execute all this statement. Read write already exists. So let me create, instead of read write, we'll say app underscore read write 1. Let's create the role. It's very, very easy. It is done. The next one is we'll create a user which is called as app reporting user 1. We'll give some password. Then we will create another user, app reporting 2. Then what we are going to do is we are going to grant the privileges. So this we have seen earlier also. There is nothing special. It is just the user and the role. The only difference is they have login access. This is done. And finally, the roles which we have created can be assigned to the user. So we had app read only, and we have app read write 1. So let's grant all this. So this object level things are very useful when you when you work for the application team and you have to grant some kind of access on the tables or a schema to the roles, and that role has to be assigned to the user. So just to recap what we have done, we have seen what is a user. User is nothing, just a create role plus login permission. Then we saw what is public schema. Public schema is something which is available by default in a database which is newly created, and the user has the access on that, which is connected to that particular database, and then they can create the objects into that. That is not a good practice to have that in place, but it is by design, so you should remove the access over there. Then we saw something as search path. If you say show search path, it will show you two value $user comma public. That means a user which is connected to a particular database by default. It will look into the schema with the same name as the user connected. If that is not available, it will search for the objects, or it will create the objects which is there in the public schema. So instead of saying select star from table, uh, or instead of giving the fully qualified name, select star from schema.table, you simply say select star from table. Then it will check this criteria, and if it is validated, it will display the results. Then we saw how to create the user. Then we created a role, read-only role. Then we created a read-write role, and then we created two users, and then we assigned the roles to the user. I hope this is going to work, and thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is bloat or bloating in PostgreSQL. So let us see what is bloat in PostgreSQL. So let's take a scenario wherein an application is trying to update an existing record in a table of a particular database. So when a update happens, it does two actions. First, it creates a new record, which is a result of the update, and the previous value of that particular record is still existing in the database or in that particular table as a dead tuple. So let's say in that table, due to the application behavior, the rate of generation of those dead tuples is more than those tuples are getting removed. It is known as bloating. So you must have gone through the auto vacuum process, wherein the dead tuples in the tables are removed due to auto vacuum. And if the rate of accumulation of the tuples in the database is more than the rate of the removal, it results in the existence of those dead tuples that they keep on accumulating. So that is known as bloat. Let us see a bloating scenario, how actually it happens. So I'm just taking the same example again. Our application is trying to update or delete the records in the database, let's say a particular table. In a minute, there are about hundreds of records. They are updated or deleted. And due to the behavior of Postgre, when 100 records are updated or let's say deleted, it results I it results in two action. If it is an update, 100 new records are generated as a result of update, and exact 100 records are accumulated as the dead tuples, which has the previous value. And if my auto clean process is running, which is used to remove the tuples, and let's say my auto clean, which is known as the auto clean process, is trying to remove those tuples, which is known as the auto vacuum process. It is removing 90 records per minute. So every minute 10 records are getting generated or accumulated as dead tuples. So this is leading to bloating. So in 1 minute, where 100 records are updated, 10 records are keep on accumulating. So you can understand how many dead tuples will generate in an hour or in a day if those dead tuples are not removed. So what is the problem they may cause to the PostgreSQL? First of all, the number of records they will be more, although they will not be visible, but in terms of the size of the table, it increases. So what it does, it decreases the performance of overall query execution, wherein that particular table is involved, where bloating has happened. And when the bloating is there in a particular table, let's say there are 100 records, 1000 records in a particular table, and due to bloating, this has become 2000 or 3000. I'm assuming that those dead tuples are not uh, uh, removed, or due to let's say we are not knowing, or due to any reason, so we have not removed those dead tuples. So it leads into the inaccurate statistics of the table. So when the query having that particular table is executed, it gives the wrong statistics of the table. Instead of having the actual 1000 rows, it has more than 3000 rows. It has to traverse. So it gives the inaccurate statistics when the execution happens for that particular query wherein that table is involved. So when a query executes, it generates an execution plan, and if the table statistics are not correct, then the execution plan will also not be optimum, and instead of giving the best results on a best time period, it will give you the result in an appropriate time. Let us suppose the execution time should be 10 seconds. Then due to this bloating, and it depends upon the number of bloated rows, it may be more than that. So it is causing a lot of problems. So it causes the performance degradation of overall database, where bloating has happened in those tables. So what are the options for removal of those? It has to be removed. So you can go for the vacuum full, which is a manual process. When you do the vacuum full for the entire database, let us suppose we are going to do the vacuum full for the entire database. It is a kind of complete downtime for the database. You cannot do anything in that particular time. So it is just like it is going to create a new copy, and the tables will be logged during that time, and you need to have double the space. uh, let's say your table is of 10 GB, then you need additional 10 GB so that it can create a new copy and can delete the older copy later. So this removes the bloat. Second is PG repack. So this is an online option to rebuild your tables where bloating has happened. And when this is not available by default, so you need to install this package. And once it is installed, you can do the online repacking of your database or the table. So what it does, it creates a fresh copy of the table without those dead tuples, and it is as good as your full vacuum, but this is not going to lock your table for like your vacuum processes doing. And last in this is the demo how to remove the bloat. So I have listed the step over here, and I'm logged in as a Postgre user. Let's log into pSQL prompt, and let us see the number of tables which I have. Let's say the databases I have. Let's go to DVD rental. So what we are going to do is we are going to do two things. One is, let us assume, although there is no bloating, I have not deleted or updated anything. So I'm going to run a vacuum verbose analyze So what it is going to do, it is going to do, uh, let's say vacuum full, and we can give the table name, or let's do it for the entire database. I'm not okay. Let me switch to DVD rental database. Yes, and now execute the vacuum command for the entire database. So you can see all the tables in that particular database are getting vacuumed. Although there is uh, no dat tuple, but it has done everything. So you can see uh, vacuuming this particular table and the index. Let's say here also public.film. This is the table name. This is the index name. So it will remove, since this is a very small sized database, but in large database it can take its own time, and this takes a lot of CPU and the compute resources. So you need to plan it during the complete downtime. And second is PG repack. So what I can do is my PG underscore repack binary is available at this. We can do some kind of dry run for the database. So let's do this. So PG repack hyphen dry hyphen run DVD rental. So we are going to do a dry run. Oh, okay, this is, I have to come out of this, clear the screen, and let's do the dry run. So you can see repacking is happening. So it is going to repack the table again, so that all the bloating is removed. This is a dry run, and when you do it, actually you will be doing it like this. Uh, PG underscore repack hyphen D, then the database name, or you can give the table name also. So you can give hyphen hyphen table and the table name. I'm doing it for the entire database. So let's see how it is happening. So repacking table. So this has done. The first one was dry run, how it is going to happen. Then there is the next one is the actual run. So just a recap of what we have seen is what is bloating? Bloating is nothing, just the dat tuples which keeps on accumulating into the database, and when your auto vacuum process is not able to remove it, the number of data tuples keep on accumulating. That is known as the bloat. Bloating scenario we have taken wherein an application is generating a number of it is going to update a number of records, and few records keep on accumulating as dat tuples, resulting in the bloating and leads to the poor performance of the database due to the size of the table, which has increased enormously, and the indexes go as well. The statistics of the table change because the actual records are named not same as the records which are present because of the dat tuples, the query execution plan go haywire because of the wrong statistics. And then we saw how to remove the bloating. We saw vacuum full, which locks all the table. Uh, and it requires downtime. Then another is PG underscore repack, wherein the repacking for the individual table happens, or for the entire database, and this is an online activity. And this is good. And I have installed it separately, and once I have repacked all the tables, I'm going to remove this particular package. So then we saw how to remove the bloat using both the process, uh, vacuum full and then PG repack. I hope a removal of bloating process is going to help, and thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is vacuum and auto vacuum in PostgreSQL. So first of all, let's see what is vacuum in PostgreSQL. So uh, let's consider a situation wherein you have a table with over a million of rows, and your application continuously updates and deletes the rows into the tables. Let's say thousands of rows are getting updated or deleted every hour. So just to maintain the MVCC architecture in PostgreSQL, what it does, let's say the 1,000 records has to be deleted due to the nature of the application, then those 1,000 rows are not getting deleted. What is done by the Postgre is they are marked as the dat tuples. That means they still occupy the space into your table, and the table size keeps on growing. That particular row is not usable and it has no dependency. So those are marked as dat tuples. So every hour, let's say thousands of rows are getting let's say piled up in your table, and within 24 hours, let's say you have 24,000 rows which keeps on accumulating. So Postgre came up with the process which is called as vacuum, wherein those dead tuples, they will be cleaned up by a process which is called as vacuum. So what is vacuum? Vacuum is used to free up the dat tuples into the tables, and these rows can be reused. So you can use that rows later on. There may be an option also wherein that row can be returned back to the operating system. So let's see what is vacuum at a glance. So what happens? When you do the vacuum, which is a command on your Postgre. So Postgre vacuum command will remove those dead tuples, or those rows which accumulated when they have been deleted or updated from the table, and they are valid both for table and the indexes, because when you update your table or delete the data in your table, the corresponding indexes are also altered. When you do the vacuum, it is not going to return the unused storage to the operating system, but those particular storage area, let's say this is marked as the tuple, which is has been deleted. This is no more usable. When you do the vacuum, this will be returned back to the table, and this can be used. So when you do the vacuum, it takes the compute from your system. It is going to take CPU, it is going to use the IO. So this has to be done only when your application activity is low and you have enough storage on your operating system. You can do something called as vacuum full. When you say vacuum full, it is a process which takes lots of compute, which is CPU and memory, and it is going to return back the storage to the operating system. So only when you say vacuum full, this is going to return the unusable storage to your operating system. But this is a very challenging task, because when you do the vacuum full, it is going to log the table. That means it is a kind of complete downtime for your application. You cannot do any operations. Even select operations are not allowed. When you do the vacuum full, it is going to create a new copy of the table, so that those data tuples will be completely removed. So you need to have double the storage, which is a kind of challenging task in your production environment. This can be only done when you are going to refresh your entire system, and consider this only if you have enough storage. So most of the time, this is not possible. So what happens when a table with millions of rows in a day and 24,000 rows are updated or deleted? The statistics of the table also gets changed. So instead of 1 million rows, there will be a minus 24,000 rows lesser in that table. So when the query execution happens and that table is part of the query, then it is not going to have the current statistics. So what you need to do after such activity wherein the table is heavily updated, then what you need to do, once you have to do the vacuum so that the unused the dead tuples are removed, and once the dead tuples are removed, you have to update the statistics of the table using the analyze command. So this will update the statistics, and the latest statistics or updated statistics are used for the query during the execution plan, and your query will be able to execute in a lesser time. So when you do the analyze, you can do it for the entire database if you think the fragmentation has the updation has happened so much. So you do two things: you do the vacuuming and you do the analyzing. Vacuum we do because a lot of dead tuples has accumulated. Analyze you do because the corresponding tables and indexes, what do you say, the stats has also changed. Uh, Postgre came up with the what do you say, the process which is called as auto vacuum. So instead of you doing it manually vacuum, Postgre will do it on your behalf. So by default, auto vacuum, the vacuuming and analyze is happening automatically at the database level. So by default, this is on in Postgre. So you need to remember some of the important parameters of the auto vacuuming. So auto vacuuming is when the vacuum is done automatically by the database. So by default, it is on. So in PostgreSQL.conf, if you say auto vacuum, this should be on. That means your auto vacuuming is working. Then there is another parameter which is known as log auto vacuum minimum duration. As the name suggests, log. So it is going to log the auto vacuuming activity when the value has been mentioned. If it is -1, that means it is not going to log the activities. If you mention the value greater than 0, then it is going to mention capture what all auto vacuuming it has done. Then another parameter is auto vacuum max workers. That means by default there will be one auto vacuum process. So that is uh, uh, in case you have n number of tables where this vacuuming has to be done, then one worker will not be sufficient. So you need to increase the number of auto vacuuming workers. So by default, it is 3. So along with your auto vacuum process, there will be 3 more sub workers which will do the vacuuming process. There is something called as auto vacuum nap time. So once the auto vacuum has launched for the first time and it has finished its task, then after what time, after sleeping for how many minutes, it is going to execute again. So it is going to execute again after 1 minute. Then we have another important parameter, which is auto vacuum. Vacuum threshold is equal to 50. If 50 rows have been updated on a particular table, then auto vacuuming is going to happen on that particular table. So vacuuming and analyzing, they work together. So once the vacuum has happened and there is a updation of 50 rows on a table, then it is going to launch auto vacuum. So vacuum and analyze is going to happen on that. There is something called as auto vacuum scale factor equal to, by default it is 0.2. That means if a table which has 100 rows and if 20% of the rows have modified or there is a change, then auto vacuum is going to launch and it is going to remove the tuples and it is going to update the statistics. So vacuum and analyze is going to happen. So auto vacuum analyze scale factor equal to 0.1. That means if a table which has 100 rows and if 10%, that means 10 rows have modified, then the analyze command is going to execute on that. And similarly, you have auto vacuum, vacuum cost delay. That means the default cost value for the auto vacuum. This is 20 milliseconds, and default vacuum cost limit. This is by default -1. So now let's proceed with the demo. So So I'm going to put this in the comment section. So what is vacuum? Then what is a manual vacuum command? Then what is vacuum full command? And how do we check whether vacuuming is enabled in my system or not? And then we'll see some of the parameters. So let's close this first. I'm going to close this out. Okay. I'm logged into the MovaXterm tool, and I'm connected to my database server, which is 192.168.1.61, and I'm on the command prompt. So I'll just say select name comma setting from pg underscore settings, where name equal to auto vacuum. So by default this is on, so this will show that auto vacuum is on. And we discussed about the auto vacuum parameters, like auto vacuum on, this is by default. Then when auto vacuum has to log all the activities. If it is -1, it is disabled. What is the maximum number of workers that should launch along with the master auto vacuum process? Then you have auto vacuum nap time, for how many minutes it's going to sleep between the second execution. Then you have auto vacuum threshold. That means if 50 tuples have accumulated, or 50 rows have updates minimum, then it is going to execute. Then you have the analyze command is going to execute when there are changes in 50 rows. Then there is vacuum scale factor 20%, 0.2. That means if there is a change in 20% of the data, then vacuuming is going to happen on the table. And similarly, analyze is going to happen if there is a change in just 10% of that. Those were the important ones. And again, that why Postgre creates vacuum, it is just to maintain the MVCC architecture, that those dead tuples keeps on accumulating after deletes or update. And finally we'll see, let's list out the databases. If I switch to DVD rental database, it will be like this. And if I do a vacuum process, vacuum verbose analyze, this is how do we do it. So you can see that it is doing, although there are no dat tuples, so it is going to do it on the indexes and the tables both. So you can see if I fire this command, so this will show how many. So it is select rel name comma n underscore dat tuples from pg underscore states underscore user underscore table. So this will show the tables in my current database, which is DVD rental. So how many dat tuples are there? If there are dat tuples, then you can vacuum it. Otherwise, auto vacuum is going to happen automatically. You can check this storage utilized by all the tables. Let me do it this way. Let's see the size of all the tables. So rental table has this much of size, and so on and so forth. So if you are doing vacuum full, it is going to take this much of storage again, and this is like creating a new copy and deleting the old one. And you can see when the vacuum has last happened on this particular list of tables, since we did it right away. So this is the current timing, and you can check. This is the way you check it. So just a recap of what we have done is We checked what is vacuum in PostgreSQL. A vacuum means it is just like that tuples keeps on accumulating in a table when those are deleted or updated, and you have to either manually remove it or it is removed by something which is called as auto vacuum process. So vacuum is nothing. It is like the data tuples keeps on accumulating in your tables and indexes when the related data is updated or deleted, and it accumulates uh, in your table. And this keeps on growing the size of the table unnecessarily, and the performance get decreased. So you have to remove those data tuples from the index and table using the vacuum command, or auto vacuum does it itself. If you say vacuum full, then it is going to lock all the tables, and it is going to use the double store. It is going to create a new table as well. So we discussed about the plan, updating the planner. So it is like in auto stats, in auto vacuum, your vacuum and analyze work together. So once vacuum happens, the corresponding statistics of the table also changed. Let's say in a table with the 1 million rows, 100,000 are updated daily, then you have to update the statistics of the table as well using the analyze command, or auto vacuum does it automatically. Then we discussed about what is auto vacuum. So when vacuum happens automatically by the database, it is known as auto vacuum, and by default it is on, and there are some corresponding parameters, and the important ones are like auto vacuum max workers and the nap time, etc. What is vacuum threshold, vacuum analyze, um, like 50%, 50 rows are updated, then this auto vacuum is going to launched, or if 20% of the rows are updated or 10% of the rows are updated, then analyze is going to kick off. And finally, we saw a very small demo. You do the vacuuming manually, and it works that way. So I hope this is going to give you a brief idea of how this auto vacuum is working, and we'll see new property of Postgre in some other tutorial. I hope it is going to help, and thanks for watching. In this video tutorial, we will learn what is val in Postgre and how to enable archiving in Postgre instance. So first of all, we will learn what is val. So val is a short form of write ahead log. So whenever a transaction is performed onto the database, let's say insert, update, delete, or any other which is modifying the Postgre database, is first written out to into a file which is known as write ahead log file. Then it is actually saved onto the actual data files of Postgre database. And whatever changes are happening onto the Postgre, uh, they are sequentially written into the val file. So it is a kind of if there is some kind of disaster, you have to recover your database, and if you have the val files, then you will be able to recover it. So you can replay the changes which has happened onto your database. So this is a short summary of val. Val is nothing. It is write ahead log. So whatever changes are happening to the database, they will be returned to a file which is known as val file, which has a particular location in the database, and there it will be saved. So the next thing is what is the location of these val files? So val files are located under data directory. So let me quickly open a shell. So I have, so let me say sudo systemctl status PostgreSQL. Sudo systemctl status PostgreSQL 12. I have PostgreSQL 12 version installed on my Linux system, and I'm connected through Movaxstrom. So you can see that the status is active, and it is in working
manner. So the next thing is how do I check the location of val? So 9.6 onwards, it is into a particular file which is known as pg underscore val, which is under your data directory. So let's go to PSQL and just say show data underscore directory, and you will be able to see the data directory location. So just navigate to that location and just say ls-mpr, and you can see there is something called as pg underscore val. So just cd to that location, and you will be able to see a number of val files which are written over there. So this is the default location of your val in Postgre environment, and the version is 12. How can we control the val? Well, let's say how many val files should be there. Let's say at this point of time I have 1, 2, 3, 4, 5 files. Let's say, will it be an unlimited number of files? So what will be the size? What will be the maximum size of those files? So there are two parameters. One is val keep segments, like how many number of these log files you want to retain on your Postgres system, and what should be the maximum size of these max log max val size. So you can see the description in postgre.conf. So let me I'll just say cat postgre.conf, and we'll just grab the value which we are looking for. So we wanted to know about the val keep segment. So there is some kind of description also mentioned. Grab minus, let's say, -i. Let me see where, oh, I'm in the wrong location. That's why it is not working. Just say it again, cat postgresql.conf grab. So without entering, I just wanted to see. So you can see that val keep segments equal to 0. At this point of time, it is disabled, and we can keep it according to our requirement. Let's say I wanted to keep 10, then I have to change this value, val keep segments equal to 10. Then there is another parameter which is max val size. So what is the maximum size which I wanted to keep? So just search for this, and you will see some kind of description over there. So as of now, the max val size is 1 GB. So in this particular file, the val file, you can see this particular file in scenarios, it can grow up to maximum of 1 GB, but if there are big transactions, then it can grow beyond the allocated value as well. So the next one is archiving vals. So what happens if this particular location, the number, let's say 10 numbers are already created, then what after that? So is it going to override that? So in that case, what we have to do is we have to archive those val files to a safer location so that we can store it over there, and in case of requirement we can restore it from there. So we will see how to archive those val files in some other directory or location, or so the archive command can be used. So there are some commands. You can say archive command in single quotes CP, and then you can mention the destination. So from its default location, it will be copied to a new location, so that it is not getting overwrite. So you have always a copy available on your disk. So if you wanted to keep it in S3 bucket on AWS, you can do that. You can keep it on Google Cloud bucket. So those options you have, or if you wanted to just archive it to a particular location, you can do that. So let us see this particular archive underscore command. So cat, I just wanted, without entering it, I wanted to see archive command. So you can see that archive command to use to archive a log file segment. The next one is wall level. So there are 3 wall levels in Postgre 12. We have something called as minimal. This is required when your system goes down, and it contains the minimum information which is required to bring your system up. Then you have something called as archive or replica. So archive or replica, in earlier versions it was archive, now it is replica. By default it is as replica, and it has enough information which is required for your WAL files. Then replica is the information which is required to for read-only queries, and if in case you are building a standby server. And logical, that's the highest level, so you can extract the logical changes which have happened. And so to enable the archiving, if I have to enable the archive, the wall level should be greater than archive. In our case, it will be replica. Archive timeout, what is that? So let's say I am the archive logs, this WAL files are created when the application modifies the data, and in case let's say the application is not accessing the Postgre, and there is no activity happen, then is it like WAL file is not getting created? So you can mention archive timeout equal to n number of minutes or hours. So let's say when we say archive timeout equal to 1 hour, so after every 1 hour, when the counter starts, a new WAL file will be generated even though there is no activity onto the database. And the next one is how to control the size and number of the WAL file. So you can control the size by using max wall size. You can keep it up to the n number of GB. So in our case, we will keep it to 1 GB. And how many wall files you wanted to keep it? So let's say if I say wall keep segment equal to 10, then it will be retained to 10. Let's perform the settings. This is a demo which we are going to do, the archival setting. So the number of parameters which will be impacted is wall level. So let's vi this. Let's edit this file, postgresql.conf, and search for the first parameter, which is wall level. So it has everything. So you can see that here wall level equal to replica is already set, and this is so you have 3 values: minimal, replica, or logical. So in our case it is already set as a replica, so we already checked. And if you wanted to modify this particular parameter of postgresql.conf, this requires the restart. So this is the first parameter. Then you have max wall size. What is the maximum wall size or WAL size? So as of now it is set to 1 GB. How many segments of WAL you wanted to keep at one particular point of time into the mentioned location? So in our case it is set to 0. That means it is disabled, but we will make it 10. Then you have archive mode. By default this should be off. So archive mode, you can see here archive mode equal to off. To enable archiving, we will have to set it on, and this also requires a restart. Then you have archive command. So archive command is in our case we will use the cp command, and we will copy it to a different location. And then we have archive timeout. I think timeout is also disabled, so it is 0 at this point of time. So what you can do is either you use VI editor, edit the value, save and restart the instance, or just for this demo we can use alter system so that these value will go into postgresql.conf, and when you restart it, it will read it from there. So just for this demo we are going to perform this. So wall level is already set to replica. Then you have max val size, so we will set it to 1 GB. So what we have to do is, I'm already logged in as Postgres OS user. I'll say PSQL and we'll say alter system set max val size equal to 1 GB. Perfect. Then we will, how many val files we need? So we wanted to keep 10 files, so we'll say alter system set val keep segments is equal to 10. So let's keep 10 val segments, and let's enable the archiving so that when uh, from its default location, the val files will be copied to a new location when we give the cp command. So we have to, for that to happen, we have to set it on. The archive mode has to be set on. And then we will have, so what we wanted to do, we wanted to keep the archive logs to a particular location, which is postgre /log. So what we will fire the command is alter system set archive command equal to, in single quotes we will say cp %p, and the destination is postgre /log, and the archives will be copied in the form of archive underscore val and a unique value. So let's fire this command. Preferentially you can use vi, make the changes there, and then restart the system. Ensure there is at least one val size for archive timeout duration. So what we will do is, even if there is no activity for this Postgre environment, let's say there is no data getting changed in 1 hour, there will be a switch happen and the val file will be generated. So we have made all the changes. Now we will restart the instance. Let's come out of the pSQL prompt. Yes, and restart the Postgre 12, and now check out. The first parameter for archiving is show val levels. So it is set to replica by default. So you have minimum, you have replica, and you have logical. So for our case, for archiving, this is more than sufficient. Then what should be the maximum size of val files? So it is set to maximum of 1 GB. How many val files we can store at one particular point of time? So we have set it to 10. Have we enabled the archiving so that these can be copied to a new location? So archive mode is on. Then what is the archive command to copy the val files from their default location to a new location? So this will be copied to this particular location. So we will navigate to that and we'll see. And finally, archive timeout. So even after 1 hour, no activity happens, which generates a val file before the data gets returned to the data files. A switch will happen and an archive eval file will be generated. So if you would have worked in environment like Oracle, where archive logs are there, and in there are transaction logs in MS SQL, then you have bin log in MySQL. So it is I believe synonymous to that. Just quit out of this prompt and and we'll see if there are some logs generated or not. So we have given a dedicated storage file system for storing the archive logs of val. So you can see that this has happened, and it is in the format of archive underscore val. So just a recap, what is val? Val is just a short form of write ahead log, and this is not a feature of this particular database. In fact, most of the RDMS has this. So before the data is modified data is actually returned to the data files, there is a, a file which is created so that you have that when there is some kind of restoration required, you can restore from those files. So in Postgre, it is known as write ahead log, and whatever changes are happening onto the database, they are first returned to the val files. So what is the location? Location is data underscore directory, and it is returned under pg underscore val. So how can we keep control the size of val? So you have two parameters. One is val keep segments, how many number of vals you wanted to keep, 10, 20, 30, or whatever you have according to your requirement, you can keep it. Max val size, what should be the maximum size of val? So it is 1G in our case. Archiving vals, so you can archive the vals when your archive mode is on, and you have to use some kind of CP command so that you can copy those files from default location to a new location. Then there are the val levels. You have minimum, replica, and logical in 12. Archive timeout is when there is no activity on the database, there will be a val file generated. And how to control the size and the number we have already seen. And finally, the archival settings. So we have to set val level equal to minimum to replica for archiving to happen. Max val size, which is the size required to keep the maximum size of val files. Then you have how many numbers you wanted to keep. So in our case, we wanted it 10. So val keep segments equal to 10. Then we have archive mode equal to on. This is mandatory. Then you have the archive command. In our case, we used cp %p and the destination. And finally, the archive timeout. These either you use the VI editor, since this was a demo, so I used order system set, and I restarted the instance, and we checked all the values, so everything was reflecting as required. So archiving is happening as of now, and after 1 hour, when the timeout happens, there will be a switch also happening. So this is all about the val, what is val, how to control the different parameters, how to do the archiving. So I hope this is going to help, and stay tuned for the next tutorial. Thanks, and thanks for watching.
And welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn how to perform the routine maintenance task in PostgreSQL using pgadmin for graphical tool. So what is the requirement of doing the routine maintenance task in PostgreSQL or any other RDBMS? So it is very, very important to perform the routine maintenance task so that whatever degeneration of the file system or fragmentation has happened on the table or index label or the file system label, that can be reclaimed. We will not be talking about the file system. We will talking about only the table and the index fragmentation and some of the other commands. So there are the certain tasks which we have to perform to attain the optimum performance in PostgreSQL. Some of them is here, like vacuuming. We have a separate tutorial, detailed tutorial on vacuuming. What is vacuuming? And vacuuming is nothing like whenever there is an update or delete in Postgre tables, the rows which has to be deleted or updated do not go out of the table. They remain there in that particular table as the dead tuples. And if there are too many updates or deletes, then the size of those dead tuples, dead rows will keep on increasing. That leads to the uh, degeneration in the table performance, so that whenever any query is using those tables or the indexes where vacuuming has where data pulse has happened, then it is going to degrade the performance of the query. So using the vacuum, what we do is we try to remove those dead tuples. If you are doing the standard vacuuming, what it will do, the dead tuples will be removed and it will be available as free storage in that particular table. When you do full a vacuum, what it does, it creates a new table, and it removes all the dead tuples from there. And there is another routine re-indexing. If the table has what do you say, the fragmented, and then it is surely going to depend the impact the index as well. So what do we do in database maintenance? We do the defragmentation of the tables or the indexes or the data files using some of the methods which is given by default in the pgadmin tool. And why those fragmentation happen? It is due to it is happening due to the insert or the delete operations on the tables, which is causing or leading to the dead tuples or bloating as well. So when we do the maintenance, it helps in reorganizing the table and the indexes and enhance the performance of the database. So we'll be talking about the four maintenance process. One is vacuum, wherein the dead tuples will be removed from the table. If we are doing a standard vacuuming, then those dead tuples will be available as free rows and the storage, and they can be used later on. When we say analyze, analyze is going to analyze the tables, and that will be used by the query optimizer so that it can pick up the latest uh, statistics of the table. When you say re-indexing, re-indexing is going to what do you say, create the new index wherein there will not be any fragmentation. And last is the clustering of the tables. So vacuum, we have already discussed like what is vacuuming. Then we have discussed about what is the use of analyze. Analyze, what it does, it tells the query planner to update the statistics, and it is going to generate a good plan when those tables are getting involved in the query. And how do you generate the statistics on those tables using the analyze command? It is one of the optional step in vacuum. By default, it is disabled, but you can enable it. Reindexing can be done to remove the fragmentation from the index. So we will see how to do that. And the last one in this is the demo. We'll see how to perform the demo. Let's and this and I'm logged into to pgadmin 4 GUI tool, and I have some of the database which I had imported. One of them is DVD rental. So what I'm going to do, just right click and say maintenance, and a window will be popping up, and you can see there are four things: vacuum, analyze, index, and cluster. Vacuum by default it is no, because when you say full vacuuming, that means it is going to lock all the tables, it is going to freeze all the updates, and this that means you cannot do any kind of update on the table. And if you say analyze, you can do the analyze. So by default, full is no, freeze is no, analyze is no. And if you just say verbose, you can run this analyze vacuum command. Just say okay, and it will show you the progress. So more details, we will see how it is going to do. It's just a vacuum verbose command on the particular database. So it is a standard uh, vacuuming happening onto the database, but it is not going to log the tables, or it is not going to run the analyze command. If we have to do it, you can see that it is successfully completed. You just go and just say maintenance, and if you are sure that it is a complete downtime, you just say full vacuuming, and depending upon the size of the tables, it is going to take its own time. So you will have to do some kind of testing how long it is going to take. And if you wanted to analyze, which should be done if you believe that the table statistics have changed, then you need to, let's say, the insert or the update and the deletes have changed at least 10 or 20% of the data, and it is going to impact the performance of your database. Then you can run this. Just say OK, and you will see that maintenance job is created, and it will pop up. Yeah, so more detail. So what it is doing is vacuum full, freeze, verbose, and it is going to run this command. So in the first we saw that vacuum verbose only. Now it is doing the full vacuum. It is freezing the tables also, and it is showing you the output as well. Successfully completed. Since it is a database which is just in KB, that's why it is taking lesser time. Going to maintenance again and just doing the analyze. If you just do analyze, it is going to analyze all the tables in this particular database. Just say OK, and you will be able to see what it is going to do. So the maintenance job is created. It will pop up. Just say more details, and it is saying analyze verbose. That means it is going to analyze all the tables which are there in this particular database. So if you see the data tables over here are these. So it is going to analyze all these tables. So you can see here also analyzing public dot address. That is one of the table. And if you see, it should be somewhere here. Yep. So it is going to analyze all the tables. So analyze increases the performance of your uh, uh, database, because the query planner updates the statistics, and that is used during the execution of the SQL query. We can check one more thing, and just right click onto the database, just say maintenance, and you can do the reindex. Just say OK, and you just have to tap on that particular tab, whatever you wanted to do. Just say more detail, reindex, database name, and it is going to reindex the entire database. So reindexing is completed. The final in this is the last one, which is maintenance, and you just say cluster. And if you just say OK, and this is not the task which we have automated. This is just we are doing an ad hoc. If you wanted to do it in a scheduled way, either you do it, put it into a cron job, or you do it using the PG agent as well. So we are doing the cluster verbose, so it is going to run it. It is showing successfully completed. So this is how do we do the routine maintenance in Postgre using the PG Admin 4, and it is very easy. You just right click onto the database, just do maintenance, and all the 4 options will be available. I hope this is going to help, and thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is logical replication in PostgreSQL, and following that, we will see a demo on logical replication. So what is a logical replication in PostgreSQL? So logical replication is one of the way of replicating the data and its associated change from one database to another database, or the databases may be on same host or different hosts. So we are talking about the tables wherein the individual row is actually identified using the primary key. So any changes which is happening on to the table will be replicated from one database to another database. So when we talk about logical replication, it is entirely different from what we call as the physical replication, wherein bit to bit the data is same on 2 different hosts. But when we say about logical replication, you can control what data has to be replicated from one database to another in PostgreSQL. So you have a control over, you have a fine grained control over the data which has to be replicated, and you have a good control. So in PostgreSQL, when we talk about the logical replication, we talk about two terms. One is the subscriber and another is the publisher. So the one where the application connects in the particular database, that particular node is known as the publisher node, and wherever the logical replication is replicating the data, that is known as the subscriber. So publisher is the one wherein the changes are actually happening, and subscriber is the one which is accepting those changes. So when we set up the logical replication, we set up two, let's say we set up two different hosts, and we have two different instances, we have two databases. So what happens initially, uh, we have to replicate the data from publisher to subscriber. So the initial data is same. Once the initial data is same, then using the Postgre logical replication, whatever changes are happening on the publisher will be automatically subscribed by the subscriber. So it is like changes are happening on the publisher, and the subscriber gets them onto the subscriber server or the host, and it is all happening in the real time. The way the changes are happened onto the to the publisher, the same way it is applied on the subscriber. So there is always a transactional consistency. Let's see some of the use cases of Postgre logical replication. So what we can do is we can send the incremental changes in a particular database or n number of databases from the publisher to the subscriber. Or what we can do is there may be some kind of data warehouse kind of thing wherein the consolidation from multiple databases go into a single database. Or what we can do is we can replicate the changes between different major versions. Or it is possible that I have a PostgreSQL instance which is running on Linux and another in Windows, so I can replicate the data from Linux to Windows, and whatever changes are happening, subsequent changes are happening, that one can be replicated on different hosts. Or there may be a case wherein we can share a subset of database between multiple databases. Let's say there is a table which is existing on a database A, and it can be sent to different database, like let's say database B, C, D, and E. It is not like you send the entire content of the database. Let's say a few tables can be subscribed by those databases. So that's a good use of logical replication. So a little bit more about the publication and the subscription. So as we discussed earlier as well, so the publisher node or the publication node is the one where in the application connects, the changes are happening over there, and from the publication node, the changes go to the subscriber, the one which accepts those changes in the downstream. So publisher is the one wherein application is going to connect. There will be a table, there will be some primary key, and the changes from publication is replicated to the subscriber uh, the using the logical replication. So there are some kind of restrictions on also here when we use logical replication. So any kind of DDL changes which are happening on to the publisher, they will not be replicated to the subscriber. In that case, whatever DDLs are running on to the publisher, that has to be manually applied on to the subscriber, or using the PG dump structure only you can move the those commands to the subscriber. And the sequence data, this is, I think, applicable mostly in such kind of replication. So sequence data is not replicated from publisher to the subscriber. If you are running the truncate command, the truncate command is not actually replicated onto the subscriber. So instead, you can use the delete command if it is possible. Large objects replication is not allowed, or it is not possible. Maybe in the future uh, versions it will be possible. And replication is only possible from base table to base table. That means if you wanted to replicate the views, metallized views, or partition root tables, or the foreign tables, those are not possible. And let's see the demo on logical replication, which is hosted on 2Node. So let me close this and we'll see the demo. So the demo is like this. I have two nodes, so 192.168.1.51, another is 61. So PostgreSQL 12 is already installed, and the first node will be acting as the publisher, and the second node will be acting as the subscriber. So on to the first node, what we are going to do is we are going to configure it for the logical replication. So what we will do is in PostgreSQL.conf, we will replace localhost with the IP address of that particular node, which is 192.168.1.51. Then wall level will be changed to the logical, and then we will allow the request from the second node 61. So we will in the publisher node, what will we do is pg_hba.conf, we will add the IP address of the subscriber server. So let's start that. This is my publisher server, so let's check the status. Sudo systemctl status PostgreSQL 12. Oh, it is starting. Let's say check the status. It is running. And the second step is what we will do is we will edit the PostgreSQL.conf and we will make the changes. The changes is localhost has to be replaced by the IP address of that server, and because we have to connect it from remotely as well. So I'll be changing the local host to the IP address of the server. The IP address of this server is, let me copy and paste the IP address. IP address is 192.168.1.51. So local host entry has been replaced by this. And then we will go further to well. So well level has to be changed to logical. So let's change it from replica to logical. So it is going to capture all the changes which are happening onto the publisher database. And these are the only two changes. We are doing a basic logical replication. This is done. Then what we will do is we will add it pg_hba.conf. So this will make sure that the connection from subscriber server is allowed. So we will go to the section IPv4 local connections, and we will add the entry. So the entry will be host all databases, all users from 192.168.1.61 using the password method can connect. So we have to tell the publisher that this is going to happen, and you need to allow if there is a connection request from the subscriber server. This done. Now the next step is you will have to restart it because we have made some changes. Let's restart. Let's create the database user and the table. So we'll create a database with the name create database wrapdb onto the source, which is my publisher. So you can see that database is created. Next, switch to the database, and what we will do is we will create a table, wrap table, which will have the ID, name, and price. Let's create this. This is created. And then we will create a role wrap user with replication, and login password is secret_password. You can keep any other password. This is a demo, that's why we are doing this. We can see that wrap user is created. Then let's grant all privileges on database to that particular user. This is done. Next, on public schema also we are giving it, although this is not the right way, but this is a demo, so we are doing this. Okay, so once it is done, you go to the second node, and we have to create the structure of the database. We have to create the empty table, and then we will start the application. Okay, this is my subscriber server. So we'll say uh, create database wrapdb. This is done. Then we will switch to wrapdb database. Database is created. Then we have to create the table. The structure of the table has to be created first, because DDLs are not allowed. They will not be replicated. Then what we will do is we will set up the replication. Okay, to set up the replication, we have to execute create replication on source database server. So this is my source database server. So we will say create replication, my replication. So this is done. Then you have to add the table to that particular publication. So we are saying alter publication name, and the table name. This is also done. Now we will have to create the subscription. To create the subscription, uh, we have to fire this complete command, and this has everything whatever we have done onto the source. I'll explain what is this. So we'll say create the subscription, and subscription name, connection, host is 192.168.1.51, where my publisher is running. Then port is 5432. This is the default one. Password is secret underscore password, which we have given. User is wrap user. DB name is wrapdb, and publication name we are giving here is my publication that we had mentioned. Okay, it is not accepting, so let me restart this. Systemctl restart. Okay, let me restart it, because I made some changes and I have not restarted it. Let me see the status. Yeah, it is back. And let me try the replication, creating the my subscription again. Okay, you can see that create replication slot my subscription on this is done. Now we will test the replication. Okay, the table name is wrap underscore table. So let's say select a star from wrap table. You can see there is no row on to the target, that is my subscriber. On the publisher also, we will check it, and there shouldn't be anything, because there is. Okay, let's switch to wrapdb, and then we will say select a star from. Okay, there's nothing. Let's insert one row. We'll say insert into wrap table, and the first one is ice cream. Let's insert this on the publisher. It is inserted. Let's check the status on here also in publisher, because we have inserted it. On the subscriber, fire the same command. That data should be replicated. You can see the data is replicated. Let's add one more row onto the publisher, and if you simply say select a star from wrap table, there are two rows onto a publisher, then there should be same on subscriber also. You can see that it is getting replicated. So just a recap of what we have done is we have two servers. One is publisher, and the other is acting as the subscriber. So we have on the publisher, we have changed the SUN address to the IP address of that particular host. Wall level has been changed to the logical so that it can capture all the changes in wall. And pg underscore hba.conf, we have added the IP address of the subscriber so that incoming connections are allowed. Then we have created a database, a user, and the table. And then we created a publication. Then we added the table to that particular publication. And on the subscription side, what we did is we said create subscription name, and in connections we have mentioned everything: the publisher host, publisher port number, password, user, database name, and then we tested the replication and it was working fine. So I hope it is going to help in setting up the replication, and see you soon in another video. Thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will see how to backup and restore in PostgreSQL. So for backup in PostgreSQL, we have pg underscore dump, which used to take the backup of individual databases or tables. If you wanted to take backup of all the databases, you should use pg underscore dump all. For restoration, you have two utilities provided. One is pg underscore restore, which is used to restore the backup which has not been in text format. For restoration of the dumps which are in text format, you use psql. So let's see what are the different backup formats. You have the backup format in plain text, so you can restore it using PSQL. You can take the pg underscore dump backup either in custom archive, or you can use the tar archive, which is Linux format, or you can put it in the directory format so that you have individual tables separated. These are the different connection options. When you say simply pg underscore dump hyphen help, it will show you all the options. Hyphen f stands for the file name. You can mention the file name or the directory location. Hyphen f stands for the format, so you can mention the custom format, directory format, you have tar format, you have plain text. You can mention the number of the jobs in case you wanted to parallelize your backup, and your tar backup, you can compress it using the hyphen z option or hyphen compress, 0 to 9, 0 being none, and 9 being the highest compression level. You can mention the lock, wait, timeout as well. Then you have some more backup options. You can take the backup of data only. You can include blobs in your backup. You can exclude the blobs backup. And when you are creating the dump, you can mention hyphen c, small c. What it does, it cleans database objects recreating. So it puts the drop command. So hyphen c, capital key, puts the create command in the dump option. And hyphen n schema, you can mention the schema names which has to be backed up. And if you mention capital hyphen n, you mention the schema names which has not to be backed up. Then hyphen o, or no ownership, so you can skip the restoration of the objects if in the plain text format. Hyphen s, you can mention the schema only, it takes the backup of the schema, no data. So hyphen a was just for the data, and it is for the schema only. Hyphen s, you can mention the super user username, which has to be used in plain text format. So you can dump the table name using the hyphen t table, and you can mention the table names or the pattern, whatever you like. And hyphen exclude also, if you wanted to uh, exclude the backup of some of the table or some of the table in particular pattern. Let's say they are starting with tab and something. You can exclude the privileges also when you backups. You just say hyphen x, it doesn't back up the grants and the revokes. There are different options. You mentioned hyphen d, or hyphen db name, you mentioned the database name. Hyphen h, you mentioned the host name, you mentioned the IP address. Hyphen p is for the port name if you have a non-default port. Hyphen U stands for the username, which user is specified to take the backup. -W when you mention, then your piece this backup command doesn't prompt for the password. -W when you mention it forcefully prompts for the password. Then hyphen role name, you mention the role name before the backup dump. Then you have the restoration command. What is pg_restore? It is used to restore the PostgreSQL database backup from the archive, which is created by the dump pg_dump. So pg_restore, these are the different options. -D, you mention the database name. -F, you mention the file name. -F in capital, you mention whether it is other than the text format, all will be picked up from here. So you have a custom format, you have D for directory format, T for tar format, -L, it mentioned the list, -V displays what is happening in the background when you take the backup or the restore. It is valid for both. If you wanted to restore just the data, you just say -A, it restores the data and no schema, and -clean, it creates the database objects. And if you mention -index, -index, it restores the named index which are mentioned. If you wanted to mention the number of parallel jobs, you can mention it. And -L is either used to mention the file name uh, which is containing a number of tables. You can restore the database schema using -n command. If you want mention -N, it skips the schema which has to be restored. Then you can restore the functions. You can, with small s, you can mention the schema only. With the -S, you mention the super user name which has to be used. -T, you use it for the table name. Capital T, you mention for the trigger name. And let's see the demo. So I mentioned everything here on a notepad, and we are going to use it. So if you simply say pg_dump -help, it will show you what are the different options available in pg_dump. Or you simply say pg_dump all -help, it will show you all the options which are available. So let's quickly, it's very easy. So we are going with the first option, wherein we are going to create a PostgreSQL dump file, and we are saying pg_dump -v verbose, and the database which we are going to take backup is DVD rental, and this will be dumped in this particular location. And we have mentioned -v verbose, so this will display what is happening in the background. So you can see that backup is getting created, and it is, if I go to cd/postgre/backup, you can see that backup file is created in this format. So let me remove everything. Okay, let me remove DVD stars, everything. Let me execute the backup once again. pg_dump -v DVD rental. So this is going to take the backup of DVD rental database. And if you wanted to see the content, you can see either use some editor, or you just say view command. So you can see that it is a Postgre database dump. Database version is this one, and this will create the database in the format. Let's try out the second command, where everything remains safe. Say instead of giving this arrow mark, we just give the -f, and we mention the complete location of the file which has to be created. You can see that it is getting created. It's very, very easy. And If I say pg, if you wanted to take the backup in the tar format, so I'll say pgdump -v verbose, so this will print on a screen. And if I say -u, who's the user who is going to take the backup? It is Postgre. -w in caps, it will prompt for the password. -f, this is a format, and it is in text format, plain format. And no, sorry, -f, then I am saying T, this is going to take the backup in the tar format. And for which database? It is for the DVD rental database, and this will be the tar file which will be created. And let's mention the password. So this is going to create the backup in tar format. So this is the tar file which is created. If I have to restore the backup which we have taken for the DVD rental, and first you have to create a database which is blank. So create dv-t, from which template 0 and 1 are available, and the database which we are going to create, blank database, it is restored underscore DVD rental. It already exists, so let me create DVD rental 1, DVD rental underscore new. Let's say DVD rental underscore new. So I'll say the database name is DVD rental underscore new. DVD rental underscore new. It also exists. DVD rental now. So it is getting created. It is created. So DVD rental, we created DVD rental underscore now. And we are going to restore the backup in this particular database. So we'll simply say PSQL, new database name, inverts arrow, and the location of the dump file. And just mention the verbose if you wanted to see what's happening in the background. So this is happening. So it's very, very easy. If you wanted to take the backup of all the databases, we are going to use pgdump all. Pgdump all, and let's say verbose. I think it is going to work. So you can see in the verbose format in the screen, everything is getting displayed, and it is going to take the backup of all the database. And if you wanted to take a backup of a specific table, then also you can mention. So the format for that is pg underscore dump. I wanted to take a backup of payment table, which is there in uh, in DVD rental database. So pgdump -f, which is the format. It is in custom format. Only we are taking the backup of data. -u is username. -w stands for it is going to prompt for the password. Then we have database name. Then -t, table name is payments. And just mention the password, DVD rental, I think, not rentals. Yes. Or let's remove it, and we will back it up using the verbose command. pgdump -v verbose, and enter the password. Then you can see that payment table has been backed up. If you have to restore the database of the particular table, what you have to do is you have to truncate the table, then restore the data only. It's very easy. Let's see some more example. To dump a database into a PL/SQL script, we have seen that, and using the format also we have seen that. If you wanted to do it in a custom format, we can use this for the particular database. Let's try this one, although most of them has already been executed. So this is pgdump -v verbose -f format. C is -f is file, and C is the custom format, then the database name, and just execute it. To dump a database into a directory, we use -d command. So let's do that. And let's try this. Let's go to, I think it is executed. And you can see it has executed now. It's in the directory and subdirectory structure. To dump a database into a directory format in parallel with 5 worker jobs for worker jobs, let's try this one. pgdump -v -f is the format. Then we have the directory format, then this database name, and these are the number of workers. If it is more, then you can mention it, and you can compress it as well. So -f, it's executing. You just need to know what you are doing. Then to create an archive into a freshly created database, let's create a new database, restore database, dvd rental underscore new. Let's try this one. Or let's say it as new one. I hope this doesn't exist. Yes, and then restore it from the backup which we have just taken. So it is pg underscore restore -d database name and the dump name. This is done. I'm not going to check it because if it is not doing it, it will show you the error. To reload an archive file into the same database it was dumped from, then it is going to discard, it is going to clean and create it. A pg restore underscore -d. Then let's try this one. We'll put the verbose. You can see that it is creating again. And if you have to dump a single table, which we have seen earlier as well, in the text format, we can use pg dump, and this is done. If you wanted to see the content, you can quickly see it. This is the text and readable format. So this is all about the different options available in Postgre backup and dump. And I hope this is going to help, and thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn how to upgrade Postgre lower version to higher version using pg underscore upgrade utility. So first, let's understand what is pg underscore upgrade utility in PostgreSQL. So pg underscore upgrade utility is also known as pg underscore migrator in earlier version of PostgreSQL, and it is a utility which is used to upgrade the Postgre instance from lower version to higher version. Let's say if I have to upgrade my Postgre instance from 10 to 12, I can use pg underscore upgrade utility. So pg underscore upgrade utility supports upgrade from 8.4 dot star version to the latest version. The current version is 12 and 13th is the beta version. So this particular utility, PG underscore upgrade, is not applicable for minor upgrade. That means if let's say if I'm on 10.1 and if I wanted to upgrade it to 10.2, this is not valid. So this is a utility which is used to upgrade from lower to higher version, and see let's see how it is used. PG underscore upgrade. If you say PG underscore upgrade hyphen hyphen elf, you will see the different options. The first option is hyphen small b, which represents to the uh, uh, older cluster having the executable location. If I say capital B, that means the new cluster executable location. If I simply say hyphen C, it means I can check the status whether this particular PG underscore upgrade can upgrade from one version to another version or not. Hyphen small d represents the data directory of older cluster. Hyphen capital D represents for the data directory of new cluster. And some other important parameters are hyphen small p, which represents the port number of older cluster. Hyphen p represents the port number of new cluster. You can mention the username. If there is a some other user other than Postgres, you can mention that. Hyphen v is used to for verbose. You can see the proceedings on the screen as well. So how do we use the PG underscore upgrade utility? So what we have to do before running this utility, you have to create a new cluster, and you have to instantiate it using the initdb. And once you instantiate the new cluster, in our case, the demo which we are going to perform is from 10 to 12 upgrade. So there will be one instance of PostgreSQL 10 and another will be PostgreSQL 12. So we will upgrade from PostgreSQL 10 to PostgreSQL 12. So you have to shut down the older instance, and you have to shut down the new instance as well before we use this upgrade utility. So what happens in the background when you use this utility? So what it does, it copies the data from older data directory to the newer data directory. And since there will be two cluster, one will be on 10 and another will be on 12. So you have to make sure that you give the exact location of data directory of old location, new location, binary directory location of old environment and the new environment. So this is how do we use the PG upgrade. PG upgrade hyphen D. A small d represents the older clustered data directory location. Capital D represents the new data directory location. And then a small b represents the bin location of older cluster. Capital B represents the bin location of a new cluster. So let's see the demo now. And the demo which we are going to perform is like this. So in the demo, what we will do is we are going to upgrade PostgreSQL 10 to PostgreSQL 12 on RHEL 7.5, and we will be upgrading one database, which is DVD rental, or it is applicable for all the databases which are hosted on the older cluster. So let's perform it. So I have listed all the steps here in a notepad. So we are going to execute this. This is a step-by-step procedure to upgrade PostgreSQL 10 to PostgreSQL 12. So I have a Linux system. The IP address is 192.168.1.56. I have the root access and I'm logged in as Mova Extreme. So in this step, first I'll check whether I have the internet activated on my system or not. So I'll just say ping google.com. So this is working fine. In the step 2, it is everything from the beginning. So I'm going to install um, the PostgreSQL 10 version. So yum install PostgreSQL 10 hyphen server PostgreSQL 10. So I'm going to install this. This entire demo is going to take at least 10 to 15 minutes. So once we install this, we have to instantiate it. Yes, the packages will be downloaded. It is very, very fast. The next step is we'll say PostgreSQL 10 hyphen setup space initDB. This is going to initialize the database, and your data directory will be created. This is done. Once it is done, you just switch to Postgre user sudo su space minus Postgre, just clearing the screen. Once it is done, you just try to start it using sudo systemctl start PostgreSQL 10. Once it is done, just check the status sudo systemctl status PostgreSQL 10. You can see that it is in running status. Now let's load sample data. So I have a database copied here in all.sql. So I'm just going to import that. Once it is done, we'll log into Postgre prompt and we'll see what is the database hosted over there. So I have a number of databases. Mostly it is DVD rental. This just to showcase like how this database will be migrated from, upgraded from 10 to 12. Just say PSQL, and so I have DVD rental, uh, DVD rental underscore new, DVD rental underscore now, restore DVD rental, and there are so many DVD rental databases. So I'll just quit out of this, and then we will go to the step 3. Um, so we have performed 2 steps, and now we are going to install the newer version of PostgreSQL. So in this, we are going to install PostgreSQL 12. So this has to be done as the root user. So we'll say yum install PostgreSQL 12-server, and this all will be mentioned in the command section. It's very, very easy. And just say yes. So this will be downloaded. Once it is downloaded, you just have to go to the complete location of the binary location, and then you have to execute it, because you have 2 clusters now. One is on 10G and another is on 12. So usr/pgsql 12 bin PostgreSQL 12 hyphen setup initdb. So we are going to initialize it. Once it is initialized, what we have to do is we will switch as the Postgre user, and we have to start the new instance of Postgre, but this is not possible on the default port, so we have to change the default port of 54322 to some other value. So what we am going to do is, so we are going to add it the postgresql.conf of 12, PostgreSQL 12, and we'll replace 5432, which is the default port, to the new port, because you cannot run 2 instances on the same port. So you have to change it to some other value. So I'm giving 5433. This is the newer port. And then we will restart the PostgreSQL. Just starting, and then check the status. So you can see we have it is running. Now we have 2 instances running as PostgreSQL. So check instances are running or not. So we will say ps-ef grab postgre postmaster, which is the main background process. So you can see one Postgre master is running out of pSQL 10 and another from 12, and the data directory are different. Now, using the pgctl, we have to check the status of both the cluster. So we'll say pgctl, and this has to be from the PostgreSQL 10 version, and then we will give the location of the data directory and then just say status. So you can say that PGCTL server is running. Then similarly, we'll do it for 12. So you just make sure that you give the location of your 10 and 12 PostgreSQL respectively. So this is also running, server is running. Then what we are going to do is we have to stop both PostgreSQL instances. So using the PGCTL only, we have to stop it. So pgctl-d data directory location, and I'll just say stop. So the PostgreSQL 10 instances is stopped. Now we are stopping the PostgreSQL 12 instance. So pgctl-d and data directory location and then stop. It is done. Just check the status using the status command instead of stop. We'll just say status. It is not running. We'll similarly check it for 12. You can see that it is not running. So both are not running. We can check it from the background process, which is ps-ef grep postmaster. Just execute it, and there you can see there is no output. This is just reflection of the command which we executed. Now we will check if the cluster is ready for the upgrade or not. So I'll explain the what is this all script is about. So this is PG upgrade, which is from the newer so /usr PG SQL 12 bin. The PG underscore upgrade is from PostgreSQL 12 hyphen old data directory. What is the location of old data directory? Or the location of old data directory is this one. Hyphen new data directory. This is the location of PostgreSQL 12. And then we will give the location of old binary location of PostgreSQL 10. So this is USR PGSQL 10 hyphen bin. Then we will give the location of bin directory of PostgreSQL 12. Hyphen C is just to check whether our cluster can be upgraded or not. So you can see that checking cluster version, then checking database user is install user or not, then it is checking the connections, whether it can connect to both the instances or not. Then it is checking whether clusters are compatible, whether it can be upgraded from lower version to higher version, that is PostgreSQL 10 to 12. So everything is fine. So now we will invoke the same command without the without hyphen C option. So that means it is PG upgrade. We have given the location of old data directory, new data directory. We have given the location of old binary directory, and we have given the location of new binary directory. So the first option will be for the existing environment, and the next will be for the new environment, and just press enter. So this is going to take a few minutes depending upon the size of the database. You can see that creating dump of the database is schema. So it is taking all the databases one by one, and this will copy and paste from PostgreSQL 10 to 12. So behind the scenes, it is doing a number of things. It is analyzing, it is restoring the objects from from lower version to higher version. So it has created two scripts to analyze the new cluster if in case you wanted to analyze it, and the another script is used to delete the old cluster. What we will do now is we will start the new cluster. Let's stop it first. If it is started, we'll say pgctl-d and data directory location and stop. It is not running, so we can say either start it, or if it is not starting, what we will do is we will change the okay, server status is running, and sometimes it creates the problem. And what we have to do is in postgresql.conf, we have to change the port number. So the port number, let's make it 5432 as it was there in the older older, what do you say, the PostgreSQL 10. So let's start it, stop and start again, and we'll try to connect. It has stopped using the pgctl again. Start it. It has started. Let's try to log in. PSQL just says -l and you will see all the databases: dvd rental underscore new, then now, and there was a user also, which is user2 underscore remote. If something is not migrated, that it will show you like user run this script. So we are not going to analyze it now, and I just wanted to keep it for some more time, the older cluster. And if you don't need it, just go and delete it. Quit and delete the older cluster. So we have a new cluster now. So I'll revisit what we have done is, in our demo, we installed PostgreSQL 10. We initialized the cluster. Then we imported some data which was having daily rental database. Then we installed newer version of PostgreSQL 12. Then we changed the directory from 5432 to 5433 because we cannot run two instances on one port. Then we started the PostgreSQL 12. Then we stopped both the servers, PostgreSQL 10 and 12, using pgctl command, and it has to be from respective binary location. Then we, using the pgupgrade command, we mentioned the location of old directory of existing environment and new environment. Then we mentioned the bin directory location of older environment and newer environment, and we mentioned -c to check whether the cluster can be upgraded or not. And finally, we fired the same command without -c, and we upgraded the cluster within no time because the data was very less. Then we started the new cluster. We changed the port from 5432 to 5433 to 5432, and then we verified if the database is copied or not. So this was all about the PG upgrade utility to upgrade PostgreSQL 10 to PostgreSQL 12 on RHECL 7.5. I hope this is going to help, and all the commands will be there in the comment section. And thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is PG underscore base backup and how to use it, and we will see some of the examples as well. So first of all, what is PG base backup? So we have a couple of backup utilities in Postgre. So we have PG underscore backup, then we have PG underscore backup all, and there is something called as PG underscore base backup as well. So when you wanted to take a backup of a running PostgreSQL cluster, you have to use PG base backup. If I wanted to take a backup of one database at one particular time, or n number of databases, or all the databases, I have to use PG underscore backup or PG underscore backup all. In case I wanted to take a backup which can be used for point in time recovery, that means I wanted to take a backup of the entire cluster of Postgre, then I have to use PG base underscore backup, so that all the files which are there in the cluster, they will be backed up. So this kind of backup is mainly useful for log shipping or streaming replication, or you have to create a standby database, or in case you wanted to restore your database at a one particular point of time. So when you take a PG underscore base backup, it is a binary backup of your database cluster files. This cannot be used for the single database. In fact, this is used for the entire cluster only. So who can take the PG based backup? So any user who is having the super privilege, let's say the super user or the Postgre, user who is having the super user privilege can take the backup, or you have to create a user which have the permission to take the backup. And when you configure the PG base backup, you need to modify pg_hba.conf as well, so that the replication connection can be allowed. Although there is, in case you just wanted to take a base backup, you don't need the replication, but this is required. And in the demo, we will see how to do that. So most of the time when you do it either for taking a point in time recovery purpose for the data entire cluster, or you have to create the standby databases. So what is the usage? The usage is pg_base backup, and then you have a number of options. So we'll see what are the different options. So you have something called as pg base backup underscore d. That means you define the directory or the location where the backup will be stored. So this receives base backup into the directory. Then you have -f, which says which format you want it to take. There is P and T. P stands for the plain text. That means you can read it, and T stands for the tar. The file will be tarred in the Unix format. So you have something called as -x, which means do you want the val files as well, which is required for your recovery. Val is so in one of the tutorial we have explained about it what is val. So this is required for your recovery, and it has all the information. Val is nothing but it is write ahead log. So you have -x. -x small is whether you wanted to take a backup of val files, then in what mode you wanted to take it. Either you say fetch or the stream. When you say fetch, after the backup, all the files will be fetched of val, and stream when you wanted to take when you configure a standby database. That means continuously you wanted the val files to be shipped across. Uh, you can zip that as well. So -z is used to compress the tar output. So this will help you to save some storage. -z uh, it tells to what extent you will be able to compress. So compression algorithm will be applied. The value lies between 0 to 9, 0 being not compressing, and 9 is the highest. So most of the time when it is a big database, you want it to the database size is more, or the cluster overall cluster size is more, you wanted to use the compression level. But make sure that this compression is done during the off business hours, or it is going to take a lot of CPU from your system. Then you have -l, which will set the leveling for the database. Let's say I wanted to say daily uh, PG base backup, or weekly or monthly. So you can level it and you can read it later. So -p stands for the progress. In case you wanted to see if it is a database size is more, you would like to see how it is progressing. So you can mention -p. So it will show how much it has been backed up and what is the way it is going. Then you have -verbose. So when you fire PG base backup and the backup, you don't see any kind of output. You just press enter and it will come out, and you don't know whether it has happened or what was the progress. So you can use -v, which is verbose. So on the screen it will show you how it is moving. Then you have -version that will show you the version information. Then if you wanted to take a BG base backup from remote server, then you have to mention where your instance is running. So you have to mention --o host equal to the IP address or the host name of the PostgreSQL server. Then the port, if it is a default port, it is fine. If it is non-default, then you have to mention the port number as well. And in case you wanted to see the time interval status packet which is sent to the server, you can mention -s. And if you are using if you are using a user other than Postgre, which should be used because Postgre is not supposed to be used for such operations. Once in a while you can use that, but if you have to configure a backup, then you have to use a different user. So in our demo, we'll see that. -w, it will now not prompt for the password, which is not good. We will use the password, so we have to use -w, which will forcefully allow us to uh, input the password. And I think this is more than enough about the introduction, and now we will see how the demo is going to work. So I have a Postgres server which is running on 192.168.1.61 Linux system, and I have a Postgre 12 running on it. So let me show you that. Sudo systemctl status PostgreSQL 12, and I'm logged in as Postgre. We'll see what are the different steps. So in the prerequisite, what we will do is we will create a role which will take the backup of the entire cluster. Then using create username with the password, and in the encrypted format will give the password. Then what we have to do is we have to add that particular user in pg_hba.conf file to allow the backup. So that will give the host replication, because there is no database with the name replication, but this will be used either for the replication or taking backup of the entire cluster, and the username followed by the IP address from where you wanted to take backup, and then subnet. Then we wanted to enforce password prompt, so this will do that. Then we have to we'll check that whether it is entered properly or not. Then we will reload the configuration. Then we will fire the backup. So let's log into pSQL prompt. So you can see I'm already logged in as to the prompt. Okay, I have already created a user with the name replication user. So let me drop that. Drop role replication_user. Yes. The first step is we'll create a user. So we will say create user replication_user with the replication. With replication means this will have the replication privileges associated with that, and then we will give a password. So this is a demo, that's why I have given the password as password only, but that should not be the case. And just say du, and it will show you the role which is created. So we have created the role replication_user, and as a prerequisite, this should have the privilege of replication. So it is having that. In the next step, what we will do is we will add this role to pg_hba.conf, so that backup it has the ability to take the backup. So let me go to pg data. Uh, so I'll exit of this prompt, and we'll say vi and pg data, which is the base directory, then pg_hba.conf. Scroll down to the bottom, and we have something called as replication privilege. So you have to add in this section. So it should be like this: host, then database. You can see it is under the section database, but there is nothing like replication database. This is required because this should have the replication privilege. Then the username. The username is replication_user. Then the IP address is localhost only, but if you wanted to have it from many other servers, then you have to give the range of the IP address, and then I'll give MD5. And I added this earlier as well, but just to show what are the different entries we put. So we'll have to give host, then replication. That means it has the privilege of replication, then the username, then the IP address or the range of the IP address, subnet, then the what authentication method. So we will give MD5 over here. Now after that you have to reload this. So we'll say uh, okay, PSQL-C, select pg reload underscore conf. Just reload this. Yes, this is done. Now what we will do, we'll see a basic demo wherein we'll say pg base backup hyphen u replication user hyphen d, and let me show you the pg underscore base backup hyphen hyphen help. So you can see that pg base backup takes a backup of a running PostgreSQL server. And what is the usage pg underscore base backup hyphen options? Then we have hyphen d, which stands for you mention the directory location. Then hyphen f, you mention the format, whether it is plain or tar. Hyphen r, you mention the rate at which the transfer has to happen. Then you have table space mapping in case you wanted to map it. Then you have the location of the val directory. Then what kind of val method it has to extract, whether it has to fetch or it has to stream. Whether you wanted to zip the backup file, or to what extent you wanted to compress it 0 to 9. Then you have, these are the basic stuff like you do the checkpoint, otherwise it will do it automatically. You create the slot, it create slots when it starts. You set the label, and you set the if you say hyphen progress, this will show you the progress. Or the connections options are if you are doing it from a remote server, you just say the host name, the port number, then you mention the username, whether you wanted the password or no password, so everything will be mentioned. So let's perform the first demo. So we wanted to use this particular location as our destination for the backup. So let's go to this location and remove if there is any data. There's nothing. This should be owned by the current user. My current user is Postgre. And we'll say pg base backup hyphen u. The username is replication underscore user, and hyphen d, and the destination. So this is a very basic backup of pg base backup. Just press enter, and this will prompt for the password of replication user. So we mentioned password as password only, and it is happening in the background. If you go to this location, you will see that the files are backed up now. So these are the different files, and this is the same file which is there in PG data. So let me open one more session, and I'll just say sudo su space minus postgre, and I'll do cd dollar postgre data. This will take me to the default data directory location. And if I do cd to this location, you will see there are so many files. So if I say ls-ltr and count the number of files, you have 27 files. And when we took the PG base backup, you can see everything is here. So if I say ls-lrt wc-l, you can see almost equivalent number of files are there. So if you see pg underscore val is here, and if we go here, so you can see pg underscore val, pg underscore two phase, pg underscore two phase. So whatever was there in the data directory, everything, including the configuration file. So this location is my backup location where we have just taken the PostgreSQL backup in the text format. Right, so everything is here as it is. It has taken the backup of pghb underscore conf. It has taken the backup of postgre.auto.conf. It has taken the backup of postgresql.conf, and everything, pg back underscore version, pg underscore tablespaces. So everything it has taken. So that's the advantage of using pg underscore base backup. It takes backup of everything along with the val, which is write ahead log as well. So we saw that pg underscore val, if you include that, it will take that as well. So here it is. If you do cd here as well, it will show you it has taken the backup of that as well. Now let's do one more um, backup, where in what we will do, we will tar it. We'll take a tar backup. So let's go to cd and let's remove everything from here. The backup which we had taken rm minus rf, and we have deleted the backup now. Just say ls-ltr. There is nothing, and this is the backup location. What we will say now is pg base backup, the utility name, -u, username, -d, the destination, and then these. Okay, I was supposed to show you the progress as well. So let me execute the backup once again using the same command. So pg base backup -u, username -d directory. So this was, if you don't mention anything, so this is going to be the default text base backup. If I say just -v vervo, so this will show you the backup status on a screen as well, like what's going on. So if you see that it is initiating base backup, writing for checkpoint to complete, checkpoint completed. So when you see this, I think it makes more sense instead of just you press enter and it gets completed. So let's remove the file over here. So I'll just remove everything from this directory. Now in the second mm, demo, what we will do, we will perform pg base backup -u, username -d directory, then -f, that is the format. If you wanted to use text format, you can do that, or you can take the tar back. Sorry, it is tar backup only. The first one was hyphen plain formats. If you don't mention, that will be plain. So this one we are going to take tar backup -z. We are going to zip this -p. This will show us the progress as well. So just press enter and feed in the password. So you can see it is showing you the percentage as well. If you wanted to make it more, what do you see, the informative, let me remove it once again, rm minus rf. You can see that there is base dot. So it has taken the two backup. One is base backup, another is for the val files, which is write ahead log file. So it has taken it in two different zip folders, zip, yeah, a zip file. So let me remove everything from this location. Now what we will do, we'll fire everything same with the hyphen verbose. Feed in the password, and you can see that along with the percentage it is showing on what is going on. Although though it is a very small database, but in the bigger environment you will be able to see the difference, like what all is going on, and with what speed it is moving on. The hyphen p is for the progress only. And if you wanted to do it from a remote server, you can do it. You mentioned the hyphen h, the IP address or the host name, then you mention the port name also, so you can do that way. This is just a basic introduction and how to use the PG based backup. So what we did is we created a user. So just a recap. First we created a role, replication underscore user, and we given it the replication privilege. Then the second important step is you have to add that replication underscore code user in pg underscore hba uh, pg underscore hba.conf, so that it can take the backup. So that will be in the last option where replication is mentioned. So host, this is not the database name, but this is the privilege. Then this is the username, which is replication underscore user, and then from which IP address. If you wanted to give take it from the other, you can mention the IP address of that, and then PG MD under MD5. That is, it will prompt for the password. Then we reloaded the configuration. Then we took the backup, and there are different options which we have discussed. I hope this is going to help, and mostly this is helpful when you do restore the point in time restoration on the same server with the WAL files, or onto the different server when you create a standby database, a standby server, or a streaming replication. So in those scenarios, it is useful. I hope it is going to help, and thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is PG repack, or what is the utility which is used to rebuild the tables online in PostgreSQL. So what is PG repack utility in PostgreSQL? So PG repack utility is a utility which is used to rebuild PostgreSQL database objects online. So this particular utility, pg underscore repack, is not available by default. This is available as an extension, and when you wanted to use it to remove the dead tuples or bloating in the tables or the indexes, you have to use this pg repack extension. You have to explicitly download it, use it as an extension for removing the dead tuples and bloating. So this is somewhat similar to the auto vacuum which we use to remove the bloating or dead tuples in the tables or the indexes. But what it does, apart from what auto vacuuming is doing, it is restoring the physical structure of the clustered indexes, and and uh, it actually removes the bloating, which is sometimes not possible by the auto vacuum process. What are the advantages of using PG repack? PG repack utility, it releases storage from the table to the file system. So the dead tuples which is occupying the storage in the tables or indexes, which is leading to the slower performance of those tables which are included in the query, it removes those storage back to the file system. And this can be used for rebuilding a table wherein bloating has occurred and auto vacuum process is not able to remove it. And when you rebuild a table, it of course reduces the IO, because the size of the table becomes smaller in terms of the number of pages which it is going to use. and it actually releases the dead tuples which has accumulated as the bloat in the tables, which auto vacuum process is not able to release. So now we'll see the demo on PG repack. So there are three steps. So we will see how to install PG underscore repack, because this is not available by default. You need to explicitly download this utility. Then we'll see how to bind it to a particular database wherein we have to use this PG underscore repack utility. And then we will rebuild a couple of databases and we'll see how it works. So let's see the demo. And so I have a Linux system where the IP address is 192.168.1.56, and we will see how to perform it. The first step is how do we install the PG repack extension. So we'll say yum install PG underscore repack. I'm using the version 12, so I will be using this PG underscore repack 12. So this is going to take less than a minute or so, and I have the internet connectivity on this server. I'll just say yes, and this utility will be installed within no time. This is done. The next step is you switch to the Postgre user. We'll switch to the Postgre user. And once it is done, we'll just run PSQL. Just run PSQL. Okay, let me see if we have started server or not. Sudo systemctl start PostgreSQL 12. So let's fire PSQL. Okay, it was down, that's why we were not able to connect it. Then next what we will see, what we will do is we will say set shared underscore preload library is equal to PG underscore repack. You need to get this enabled, shared uh, preload library, so that we will be able to use it. It is saying that shared preload library cannot be changed without restarting the server. So let's restart the server using the next step, wherein we will say pgctl-d $pgdata restart -mf. So let's restart it. This is restarted. Let's see PSQL. Yes, we are able to connect again. And then what we will do is we will create the extension wherein we are going to rebuild the tables online. So just let's see the number of databases we have. PSQL hyphen L. You can see that we have DVD rental database, DVD rental underscore new now, and we are going to rebuild the tables in that particular database. So what we will do is just change to that particular table, switch to that particular user, table DVD rental. And now what we will do is, this is very, very important. Whatever database you wanted to use this PG repack to run the online utility to repack the table and the indexes, you have to run this. So if I say create extension PG underscore repack, and what we are doing it is in DVD rental database. So once the extension is created, then only you can use it. And the final step is we will rebuild the tables online. So just quit out of PSQL, and what we will say is we will rebuild the tables online. So there is a table called as actor in this particular database. So first thing we can do is we can do a dry run. Let me clear the screen, and then we say pg repack -dry -run -d database name table, and the table name, and the table name is actor. Okay, I need to give the complete location because I have a couple of instances running, so I need to tell the exact. Either I set the location using path, I set the path location, or I can use the complete binary location. So let's say pg repack hyphen hyphen dry run hyphen d database hyphen hyphen table name. Okay, dry run enabled not executing repack. So just to, this was a dry run. So let's do the actual run now. And same thing without hyphen hyphen dry run. Okay, uh, I need to give, or I should have, let me export path equal to $path colon, let me give the binary location. Okay, pg repack hyphen d database. So you can see that repacking is done. Let's try it for the entire database. So first we will do the dry run and then we will do the actual run. pg repack hyphen hyphen dry run hyphen d database. So let's perform this. So dry run enabled, not executing repack. So let's do the actual run now. It's very simple. What we are saying is uh, pg repack hyphen d, then database name hyphen j, the number of threads, and we are going to run it in parallel. So you can see that it has taken all the indexes, tables of that particular database. So this is done because there was no um, dat tuple and the what do you say, the bloating in the database tables or the indexes, so everything was fine. That's why it came out. Otherwise, depending upon how many dat tuples or bloating you have, it is going to take its own time. You can run this utility remotely as well. If you wanted to drop the extension, you just say drop extension, extension name, and you can remove that. If I try to run this command onto a database where this particular extension is not enabled, it will not work. So if there is a database with the name dvd rental underscore new, so let me show you that. PSQL hyphen L, you can see that dvd rental underscore new database is there. So let us try to um, execute this dry run in that particular database. So dvd rental underscore new, we are trying the dry run. So dry run enable not executing repack. Let's try to actually run it. I'm not sure if I actually executed the extension command in that. If it is done, then it will work. I think I have already done it. That's why it is showing. Otherwise, it will throw you the error that first the extension is not enabled. So in that case, you have to enable it and then you have to execute it. So just to recap, what we have seen is PG repack utility is used to rebuild the Postgres databases objects online, and it removes the bloat from the tables and the indexes, and it restores the physical order of cluster indexes. So what you have to do is first you have to install this extension. So I have a Linux system, so I just mentioned yum install pg underscore repack 12 because I have the instance 12. Then you have to set the shared preload library, which is equal to pg underscore repack. Then I have restarted the instance. Then the particular database wherein you have to enable this online activity, you just create the extension in that particular database. Then using the pg repack utility, we have done a dry run for the database. Then we actually removed that hyphen hyphen dry run. Then we actually did it for one table. Then for the entire database, we have tried it. And in case you wanted to drop the extension, you have to just say drop extension, extension name, and then finally because once your activity is done, you can remove the pg repack utility. And this is all about the PG repack. I hope this is going to help, and thanks for watching.